finishing off the week with a very important member of the SLOOH community, SLOOH's CEO and founder, Mr. Michael Palucci, which is very exciting. Happy to introduce him, and I'll turn it over to him from here.
Thank you, Anna. It's a real privilege for me to be here today. I so appreciate everyone's excitement and involvement in SLOOH. Big shout out to Tyler and Hanson. I mean, this is incredible. You kids are so lucky to have people like this in your community who care about this, love this, and want to share it with you. So I hope you've enjoyed the week. I know you have. I know our team has just been thrilled to be a part of it. Every single one of them has come back excited about it. We love the energy. We don't get, you know, big chances all the time to see kids engaging directly. So I just want to thank you and thank Kathy for helping to moderate and support this. It's a great model for us, and really what we're trying to build up as we go is student leadership. And Tyler and Hanson, you both deserve some kind of achievement award that SLOOH is still developing. So when that kind of thing comes around, we will have you in mind. We want to recognize the good things you're doing and really just turn this platform over to the student leaders. That's the key. It's like it's been built so that other people can communicate about all the things they've seen and done, and that's why it's so social at its heart, and you guys really are the epitome of that. So I really want to thank you, and I want to recognize you, and I want us as an organization for you to feel like we helped you get where you belong in life, and doing things like this is huge, and we want you to proudly have a SLOOH badge someday, and hopefully that helps you get into the right college or get you that right job. There's a lot of really wonderful students who come through this platform and are doing incredible things. So it's a community that supports each other, and that's great. All right, so today, I know you've been getting a lot of astronomy lessons this week and learning all about the night sky, and hopefully SLOOH is helping to make that fun and exciting for you. I'm going to have a slightly different spin today. I thought it would be interesting to talk about how products like SLOOH get built and talk about some of the ways that happens and share a little bit about the journey to build this. And then I want to engage all of you in that process. There's nothing more important to us than user feedback. And as I said, we don't get the chance all the time to engage with students. So hearing what you have to say about this product, for me, is what this week was all about. And I want to tell you that the key to making something like this, you can have a vision of what you want the world to do, but that's really like step one. And there's been about 1,000 steps after that that have all had to do with how do human beings of all ages react to that thing. What do they think about it? How do they perceive it? How does it get better? And we don't sit here at SLOOH in a room dreaming up all of these ideas. We really develop them in response to what we see our users doing, what they want to say to us about how it could be better. And, with something as complex as this, that's serving so many different types of users of all age groups, and really coming here for different reasons. I mean, some people are coming here because they dream of being an astronaut, and this is a step on that journey. And other people are here because they just got to get through science class. And some other people are here because they find space peaceful and meditative. And so we are trying to figure out how to accommodate all those different types of people. And the they're all wonderful, and that's the beauty about space. It just is engaging, and it's kind of fundamental part of being a human being to say to yourself, what are we all doing here, and what's out there? So that that kind of means we have a lot of different kinds of people to listen to, and that includes this group of 10-year-olds, and I think you're 10-year-olds, and it also means that you know better than I do what a 10-year-old would think about this. I only know what I might have thought of it when I was 10, and I wish it had existed then, but it didn't. So here we are. I'm sharing my screen, and I just want to transition to telling you a story that exemplifies the point I just made about how we learn from our community and how that informs how this product has evolved. So, hang on a minute, I just gotta find you guys again. Where did you go? Got too many screens open. Can you see my screen? I assume okay. Um,
Yep.
We can see your
okay.
screen fine.
Okay, cool. Okay, so does anybody know what Algo the Demon Star is? Have you guys seen Algo the Demon Star? Has anybody seen the Algo the Demon Star quest? Maybe you have, maybe you haven't.
I,
Well,
I've seen the quest, and I've heard of it, but I don't know nothing about it.
okay, cool. Well, I'm going to talk to you about Algo the Demon Star because it's one of my favorites. And this relates to a story about the night sky that people have been telling for thousands of years. So we all know there are constellations in the night sky. And one of my favorite constellations is the constellation of Perseus. And if you know about Perseus, you know that he was the slayer of Medusa. And Medusa is the witch lady with snakes in her hair. And this is a story that the Greeks told, probably 2,500 years ago. And they, of course, came up with a lot of the constellations. And they basically looked at the stars and they said, oh, this is the constellation Perseus, and there he is with his sword, and he is slaying Medusa, and he's cutting her head off. And they thought that it was Medusa because there was this star that they ascribed to be her eye, and they called it the demon star because it pulsated like you're seeing right now on my screen. And that was the way that they tried to figure out the world around them. They didn't really know what it was. They just figured this is what it is. It relates to these stories we tell each other. And so for 1,000, 1,500 years, people thought about this as a star that blinked and it was evil because it related to that story. And what I love is that this teacher, Cameron, in 2018, he posted this image and he created this 4-hour time lapse. So you see that this is basically over 4 hours. He captured the pulsating demon star. And then Cameron explains in his copy that the reason this is pulsating is because it's not just one star, it's actually 2 stars, and they're orbiting around each other. And one of the stars is much brighter than the other star. And so when the less bright star is in front, it doesn't seem as bright. And then when the brighter star comes around and is more visible from Earth, it pulsates like this, and this goes on for all of eternity every 4 hours. And so we saw Cameron post this, and we were like, oh my God, this is such an incredible thing. And we realized that because we had licensed these books that are known as Burnham's Celestial Handbook, he wrote about all these things. And he wrote these books about 100 years ago. And he basically made sure that we never forgot the stories that the ancients told themselves about things like Algo the demon star and why they thought it was a demon star. And then at some point, somebody with a telescope discovered, hey, I can explain why that's not a demon. I know why that's not really Medusa. It's just because it's two stars orbiting around each other. And it's a great understanding of the way the world has evolved as it relates to astronomy for the last couple of thousand years, that somebody came along and used science to kind of debunk this mythology of what people used to think was the truth. And you can read about this story here because they're all labeled in these guide pages. I don't know if you've spent any time on the guide pages, but all of the SLOOH 1000 objects have guide pages, and they tell you about the science. This is 92 light years away, and it's actually a triple star system, I think, has now been discovered. And it tells you when you can see it. And so it's visible from June to April in the Canary Islands. And so if you want to image it, of course, this is the place to figure out when you can image it. And then you can read about this. And so after Cameron kind of turned us on to this thing and showed us what a great tale it is, well, then we turned around and we made a quest about it. And so there's a quest in here. I think you have to be an advanced user maybe to do it. It's called The Blinking Eye of the Gorgon. Let's see if our search works. There, it does work. That's amazing. The Blinking Eye of the Gorgon is a quest that you can do. And it's basically going to tell you everything that I just told you and help you figure out how to create your own poster where you can understand the mythology and the object and how these two stars, this binary star system, how these are orbiting around each other and why it's obscured. And so that's just a good example of like how we value people showing us what to think and how to explore using SLOOH. And it's really one of my favorite quests and my favorite ideas, and is part of the reason I love space and this platform. We also have another quest that I helped write. How do we spell Burnham? It's called Burnham's Labyrinth. And this is fun, although it's not in season, so you can't do it now. It'll come back online in August. And this quest is designed to be kind of like a riddle. So Burnham obviously wrote all these great stories. I took some of those stories and I turned it into a little riddle that you can try to solve. And we're going to have way more quests like this coming up that are kind of more fun, more scavenger hunty type of thing, and are just kind of trying to tell more stories. Obviously, we need this thing to work in school and be aligned with your school work and your curriculum, but there's a lot of fun to be had. And so I would love for you guys to try to do this later in the summer. But as we talk about this a little bit later, I really want to try to get some of your ideas for what you think would be compelling quests. Now that you've done some quests, now that you understand how the system works, we really want to take some of that from you and turn it into some ideas. Okay, I don't know if we'll have a little more back and forth chat in a minute. I'm going to share my screen one more time, and I just want to take a peek at your workspace. I hear you guys have been active in there. I'm going down to the summer camp, and let's take a look at some of the things that you posted. Oh, cool. So you got the all-sky camera in here. I love it. Who is this? Andrew is an Albatani level. I'm going to give you some gravity points. Nicely done. The Lagoon Nebula by Andrew again. He's a prolific poster. Could have written a little bit more here, but I like that he came up with his own idea about what it is, which is exactly what this is all about. There's no wrong answers when it comes to using our imagination. Andrew here on the Eagle Nebula. I'm going to skip down to some of the others. Tyler's done some tests. Oh, we have somebody using the satellite feeds to look at ancient castles in the desert. I don't know how you got an odd number of gravity points, but I'm going to give you something there. Wait a minute. Is this a SLOOH image? Who came up with this one? Sonic Hero. I don't know if you uploaded that or if that's a SLOOH image. That looks fake. You're a troublemaker. Did you upload that image from somewhere else? We'll let it slide this time. I love it. We got the moon from Eddie Lee. Nice, Eddie.
Yeah.
Cool, man. And Mars, the Roman god of war. Excellent. Maybe you want to pair that with an image of Mars. Whose is that? Unicorn Hero. I see a lot of aliens. Is that everybody's favorite avatar? That's great. These are great, guys. Well, I'm sure you're all learning from each other. Oh man, this Andromeda is pretty cool, Wilfred.
There's a
Okay.
question in the chat. Why do you give so many gravity points?
You think I'm too generous? Because you know why? I want people to celebrate this community, and this is one of my favorite things to look at SLOOH, is the Hall of Fame. And then you can see the total number of gravity points that have ever been earned by anybody on the platform. So we're up to 47 million. And this is like all the community's accomplishments. So every time we give each other a like, we give each other gravity points, we're basically showing how much we're all learning and how we're sort of building a strong community. And I feel like you can be generous with gravity points because they don't cost you anything anyway, right? It's just recognizing people for doing something pretty well. Are there any more questions? Okay. So now I'm going to give you guys some homework. I'm going to ask you to fill out a survey that tries to get at what you think of this product. And I want you to be brutally honest. Don't try to flatter or make me feel better if you don't like it. We love criticism more than anything. We love people who say it's good, but it could be better in this way. And that, if you're going to be an entrepreneur and you're going to build something, you want to be proud of it, but you don't want to be too proud. You want to always make people feel like you want to hear from them and understand what they have to say about it. Because that is the way, of course, we all learn about anything. Eddie says prepare to get criticized. I love it, Eddie. All right, so what I'm going to do is I'm going to post this in the chat, and I'm going to ask everybody to take your time, and once you filled it out, then we can have a discussion. And you can talk to me about some of the things that you put down here. Some of the questions are multiple choice. Some you can select more than one answer. And then there's an opportunity for you to write things in. And those ideas we can have a nice conversation about. And let's see together if we can come up with ideas to make SLOOH better. And then at the very end, I'm going to give you a sneak peek of some exciting new features coming that nobody knows about. And you'll be the only people in the whole world. All right, there's the form. I really appreciate you filling this out. I want to make sure you understand it's anonymous, so you can be brutally honest if you want, and then you can understand I'm never going to know who it is, although I bet I'll be able to tell who Eddie is. But really, truly, we welcome the criticism, and you're heroes for helping us think about this product. So why don't we take 5 minutes and fill out those forms, and I don't know if we should do anything in the meantime or just sit quietly while you're doing that. Let me know if the form doesn't work. One more minute. One more minute.
Wait, hold on. For what features did you like most? It's not a multi-answer. That's sad.
It's not a what?
Because it only allows you to pick one answer.
Let me see. Oh, you're right. Those should be check boxes. That's okay. I go ahead and just choose the one. Thank you. Okay, that's 5 minutes. So while some of you may be still finishing your form, feel free. Anybody who wants to start laying into this platform how you love it, how you hate it, anything you might have written, anything you're thinking about, if the form didn't have the questions you wanted, Eddie, I'm going to sit here and take notes with my pad. I'm going to listen to you guys now. However you want to talk, there are no wrong answers. I guess George has raised his hand. That's polite. George, go for it.
Hi. The SLOOH website, it was really enjoyable and relatively easy to use. The GI it was really good with the box at the top showing the dashboard, telescopes, all of those things. I did come across some problems. For example, when I went to the workspace to my camp and click add observations, I couldn't. But I did take pictures and it shows the pictures on my dashboard if I scroll to the bottom. So that was a problem and it wasn't in the questionnaire. So I want to point that out.
Got it. Thank you. So some of these issues will be what I would call bugs, where you might have run into some things that should have worked but didn't work. And then some of these things I would say would be feature requests, where you're like, hey, I wish it could do this. And then some others might just be plain criticism of like, boy, this was confusing, or I don't like the way this works. So any category of feedback we love, and I'm going to classify that as a potential bug and put that in the bug team. Thank you, George. Anybody got some thoughts they want to share?
There's 2 hands raised.
How do I see them? You call on them if you would.
Okay, Arav. Sorry if I'm not pronouncing that well.
It's okay. One thing which I found was not good was they were giving too many gravity points for only putting a comment. So I think they should change that.
I love it. Too many GP for commenting. And that's an incentive for people to just write nonsense, isn't it? Instead of really thoughtful responses.
Basically, someone could just spam cues on every post they see.
At the end of mine for that one, I said, "Looking at you," or.
And you got gravity for that. All right, we're gonna take that. I agree with you guys. I'm gonna work on that next week. I will tell you a new feature that's coming is that we have a automated moderation tool launching soon, and it will help weed out things that are spammy. So good feedback, guys. Keep it coming.
Sorry. AQ. Go ahead.
I don't know why, but yeah, I think I said it before, but even though I keep trying, I've used incognito and stuff, I can't I can't get into SLOOH for free. It says I have to pay.
Huh, well,
AQ, I can answer that for you. I think I already told you this on the second day, but you have to delete your cookies and site history.
don't know how.
There's a button right to the left of the link. Like, you know where the link is? Directly to the left, there's a small button, and then there should be, once you click on that, it'll drop down the menu and it should say cookies or something.
So basically,
Oh man, I couldn't find it.
my comments button doesn't work. Is that for the same reason?
Your comments button doesn't work.
Oh yeah, it's kind of bugged. It just,
Doesn't work.
basically the comments menu just stays there after you post a comment for like 3 seconds, and if you try to post another comment, it just like doesn't show up.
For me, the
Okay.
comment button just doesn't click. Doesn't take me to anything. It's just there.
Also,
Go ahead. You can say it.
Or Tyler, you can go ahead. Your hand's raised.
Okay, so I've used SLOOH for a while now because I've used it with the astronomy club that I run at Jasper. The main thing I've noticed is that it's not really built for team-based activities. It's more for like self-done stuff. It's not really for multiple people to do at the same time.
I see. So it's not for team-based activities. For you, that means like being more social, where multiple people could be like a video game playing it from their homes with each other.
Kind of. Something like that.
Cool. All right. Well, now's a good time to unveil a new feature coming. So we are rebuilding the mission interface, and when we relaunch it, the live feeds of the telescopes will be much more social. There will be chat, there will be trivia games, and there will be live hosts inside the mission interface. So Emma and other astronomers on our team will be in there live with a video pip, like we're kind of seeing each other now, and they'll be able to talk and lead conversations. And eventually, we're going to get to a point where anybody who's somewhat qualified can host SLOOH Live. And potentially you could do it for just you and your friends, or potentially you could do it for the entire community. So we understand we need like more social engagement, and your feedback, Tyler, is right on. And there's some other things that are coming with AI that are going to also make it a little more dynamic and social. So stay tuned for those launching in the next month or two. And but I totally agree with you, and I think adults, frankly, like to socialize like that too. But more games. I think games inside SLOOH would be more fun. Like, what if we had a scavenger hunt game where we released it at the same time for you and your friends, and you could all be like, who's the first to be able to go find some specific thing in space, and you could maybe form teams and play that way.
I have a question. Like, if you put a game, it shouldn't only be the same game because like I've played this game before because it only has one game, and the only thing you can play on that is that one game only. So I think there should be multiple.
I like it. I agree. Games get kind of boring because they're the same every time. But really, one of the great things about the night sky is it's so dynamic, it's changing all the time. And so even if the games are similar, the fact is the content changes, and we're always looking for something new. So noted. You want fresh, updated games.
All right, we got a lot of questions here. Eddie, you're next.
okay. So, first of all, I think you should make the like limit infinite, you know?
Okay. Unlimited
Yeah,
likes.
because I already ran out of likes for today. I was just trying to give people more gravity points, and that's just kind of sad, you know?
Okay.
Yeah,
Got it.
and then
You're gonna raise
they
the
need
limit.
to, yeah, They need to increase the amount of observations you can post in a week. Now I know that might induce some spamming, especially if you have a lot of photos. But I just want to post some of my observations, and I already ran out of them for this week. And a week to a kid feels like a really long time. So
I love it. Keep going.
And then like Shri said, the comments are a little bit bugged, and let me.
What's that term you guys are using? Bugged?
Bugged.
How do you spell that?
Bugged.
Bugged. Okay, cool.
Yeah.
I'll start using that term.
You want to know where it came from?
Bugged.
Do you want to know where it came
Yeah,
from?
so basically,
Bro,
if the mouse flew into the computer, then you'd have Bruh. But
Eddie
was trying to explain that.
Yeah, let's go one at a time. Eddie, you can finish, and I see Alexander, your hand's raised, so you'll get to go after.
So basically, back in the old days, computers would malfunction because bugs would accidentally run into their circuits. So eventually, malfunctions would be called bugs.
That's good. Thank you, Eddie. Keep going. You're on a roll.
That's it.
All right.
Well, that's great feedback, Eddie. Thank you.
All right, we're going to go Alexander and then Shri.
I think it's kind of annoying that during missions, they only pretty much send you 2 mediocre quality images. Sometimes they aren't even actual color, they're just black and white smudges.
Well, okay. I mean,
that's kind of annoying since most of the time the missions are in the middle of the night.
I see. So I'm gonna say to you that the reason those images don't come out great all the time is because it's real. We're dealing with, weather and the moon sometimes getting in the way. And so part of the beauty of this is that it's real. And I know you guys are used to, AI and movies and everything's supposed to look perfect all the time. But you guys know that we're not all perfect. Nothing's perfect. And what we try to do here is to be authentic and real so that you get an experience that feels natural and that teaches you how to think like a scientist. And a scientist would say, why does this image not look good? What happened today? And then you want to try to figure it out, get to the bottom of it. And usually it's because there's humidity in the air. And when there's a little extra water in the clouds and in the air, things can get blurry. It's also when the moon happens to be close to the object that you're looking at, that will affect the quality. And so we try to give you all of this information on the platform so that you can actually make a judgment for yourself about what's going on. And if I go back to, let's go back to that guide, we'll go back to Algo. Excuse me, Algo. And if we go back and we look at this page for the missions, it tells you a couple of key things you need to take into account when you schedule a mission. So first of all, is the moon going to be high in the sky? Because the higher the moon is and the more full the moon is, it's going to affect the imaging. The other thing that affects the imaging is how high in the night sky is the object when you're trying to image it. So an object that is higher in the night sky is going to be imaged better than one that is lower in the night sky. And that's what this graph is telling you. So I can tell you right now that if you wanted to image Algo the Demon Star, getting a mission at 5 o'clock UTC time would be better than getting an image at 3 o'clock UTC time. And you can see that this object is rising. It's red because it's basically under the Earth horizon. Then it's rising up in the horizon. We won't even let you image it until it's 20% above the horizon. And the reason for that is because if you have to look through Earth's atmosphere to see the object, instead of looking straight up through Earth's atmosphere, you're basically looking at tons of moisture in the way. So these are things for you to try to learn as you go to optimize your images so they come out better. Okay, keep going.
All right. A lot of good points in the chat that we can get to later. But Sri, you've had your comment, your hand up for a while, and then William will go after that.
The one thing that I would like to say is the thing I posted in the chat that got a few likes. It was the we should only have like one comment. If you can only have one comment per post, because if you want to say multiple things, you can just edit that one comment to have different things, and it stops people from just spamming comments to get higher gravity points.
Wait, Kevin had a good point too. Kevin was basically Shree's thing, but only the first comment gives you gravity points.
Yeah,
Only
sure.
the first comment gives
Yeah.
you gravity. You guys are
Yeah.
really
That's a better idea.
Okay, so that's a good idea. Only the first comment gives you gravity. That's not true today, right?
Yeah, and if you were to
Nah.
and if you wanted to reply, then you could just reply to a comment saying that no, this isn't true, but that wouldn't give you gravity points.
That's a really good idea, guys. I love
Good
it.
feedback. All right, William, thanks for being patient.
I feel like that there could be profile pictures, like custom ones, so you wouldn't have to choose the creative pictures that SLOOH gives you, and people have like more variety that way.
That's a good idea. Oh man, people love that idea. All right, I'll tell you what. If you want to send me in an avatar, William, design one. And if any of you guys want to design avatars, you can send them to us, and we will put them. Not all of them. They have to be good enough. So if you do a really good job, and you have to give it a clever name like Walian. If you make one, look at this crew. They all want their avatars. I really wish we could offer you custom avatars, but we can't yet. But it's definitely going to get on the list. But since you're special to the SLOOH community, if you design some quality avatars and you send them to Anna, we will review them, and if they meet the standard, we will put it live. It will be live for everybody, though, so you can choose it yourself, but then other people are going to choose it. Okay, is that cool? So that's the deal, and we're not going to pay you for it, so don't come back to me later for some $1 million rights. You're going to have to give us the rights for it. All right, Anna made Walian, by the way. She's very, very proud of it. Walian, she's really happy that you guys, a lot of you have chosen Walian.
Walian's popular.
I have chosen, what is this one? Does anybody else say, what is this guy?
I'm that profile picture, the one which you have.
Are you? You're my favorite kid now. What's your name?
Arav.
All right, Arav.
Arav, you have a question too, Arav. You can go.
I have a question. So, like, when you're trying to schedule a mission, it says mission failed, and like it says there was a problem scheduling it, and then it's the schedule mission button just disappears.
Okay. So I think what you would like is a button that allows you to reschedule that mission if it's failed.
No, like it's not failed, but like it just like the schedule mission button disappears right after like it says there was a problem scheduling this mission.
There was a problem scheduling this mission, and were you not clear about why it didn't schedule it? Did it try to tell you why it didn't schedule it?
No, it just said there was a problem scheduling this mission. It said retry. There was a retry button. I clicked retry, and then it took me back, and then the schedule mission button disappeared.
Hmm. That sounds like a bug. It sounds like you're bugged. There was a problem. Okay, I'm gonna look into that one. I don't really know what that is. There was a problem scheduling your mission, but I'm gonna find out. And then you had a retry button, and then you clicked retry, and then it didn't succeed.
Yeah, it didn't succeed.
Was this with the satellite or the telescope?
With the telescope.
Okay, thank you. All right, keep them coming. Who's got more?
I don't see any other hands up, but we'll give them all a sec.
All right, I'll read you my terrible poem that I wrote about Neptune. Okay, so I'm a sailor and I love boats and I love the ocean. So I took this photo of Neptune some years ago, actually 2023. Uh, Neptune's got the blues among the shining white, crowned king of the sea with ocean dreams alight. Pluto stole its thunder as furthest from the sun, for an age a commoner posing as the one. Neptune rang again, but 'twas nary a delight, ranger of the heaven, than hardly a fortnight, for planet 9 is on the rise, and blue Neptune is all right. Thank you. So if I can embarrass myself with that kind of poetry, you guys can write anything you want on your observations. And I think that's the point. Sometimes it's the science, sometimes it's just your own visions of space and what you dream. And I think one of the things we hope for this is that you will. Not everybody wants to be a scientist. I don't consider myself one. So don't be afraid to let this inspire you to write some killer music or poetry or anything that is your fancy. I think that's what this is all about. Anything else?
I have one question. Okay,
Yeah.
so in all the quests, you have to collect like too many photos, and sometimes the missions fail. So so it takes a longer time, and I haven't completed a quest yet. So I think there should be like a quest with less images to collect.
That is great feedback. And I'm about to tease another new feature coming very soon. There's going to be a lot of short quests that are more fun and that don't have so many missions in them, so that you can make posters and express yourself. And some of the school quests are pretty long. But we recognize that, and we're going to make some easier to do because we want you to get that badge and feel some accomplishment, and then move on to the next one. And then eventually you'll be ready for some of the most insane quests, like the collecting quests
Like
that require you
I'm
to
trying
collect
for the
hundreds of
SLOOH
objects.
100.
I've been trying for the Messier quest.
Oh, nice.
I've got
Messier. He's a
I've
Frenchman. You got to pronounce it like a Frenchman. Messier.
I've got 4 objects so far.
All right.
I'm
You got
trying to
4
collect the SLOOH
Messiers, and
100.
how many SLOOH 100s?
I don't know, but half of them aren't visible.
I have
Like
8
8 so
SLOOH
far.
100. I have
8.
8 SLOOH 100s.
I have 40 SLOOH and thousands though.
Awesome. It's really great, guys. I'm very happy to hear it. Anna Palucci, is she giving you an applause?
Yes, you guys are impressive. I'm excited even after the camp. Keep posting your observations, and I'm going to keep looking at all your gravity points and your progress. So, and when you do complete quests, post the posters in there too. I want to see them.
Hey, I forget who talked about that blurry image, but this image here, I captured actually, it was a long time ago. It was from 2004. But you can see how blurry it is because also the telescope wasn't as good then. And there's other things that affect the imaging quality too, including the instruments. And occasionally the instruments have a bad night, like the equipment doesn't work perfectly. So you could also see that. But these are some of my other images. So are you guys excited about the profiles that you're building?
Yes.
Awesome. Well, I'm really excited to see your progress with this. And you saw that one of my questions was, do you think you're going to continue using SLOOH? And you're all getting accounts for a year. So I really hope you keep going with this on your own now. I'm sure that Tyler and Hanson will be available to continue supporting your exploration. But our dream for all of you is that you find your place in space and that you think about this and you go to sleep at night and you dream about space and you think about it potentially as a career. And maybe, I mean, I really think by the time you're my age, every one of you will have been to space. That's what I would guess. That so many people are going to be able to start going to space, and it's not going to be as crazy a thing as it is now. And the more gravity points you get, and the more badges you get, you're going to be able to say to people, listen, I've been exploring space since I was 10, and I'm like a Hubble level on SLOOH. And when there's a line forming about who gets to go to space, you're going to be able to get to the front of it. Because people are going to say, yeah, you do love space. And there's so many exciting places to work in space, jobs. You're going to learn how to track satellites in space with our telescopes. That's a new thing that's coming. So that you're going to be able to like find a Chinese spy satellite and take an image of it. And then you could send it to the Space Force and be like, hey, I'm watching the Chinese satellites for you. And then they're going to try to recruit you to join the Space Force. So that's a big thing that's coming. Another exciting thing that's coming is just like we have a solar telescope, we're going to have a telescope that looks at the moon all the time. And that telescope is going to launch, I hope, in a couple of weeks. So whenever you log in and whenever the moon is in the night sky from the Canary Islands, you're going to be able to look at the moon. The other thing we're launching soon is a bunch of cameras that just look for meteor showers. And you're going to be able to see incredible meteor showers on SLOOH. And every day you wake up, you can log into SLOOH and see all the meteor showers that this camera captured last night. And get your own photos of meteor showers, and they're really awesome. I wanted to have one handy for you. I don't have it. Maybe Anna can share it. It was in the Slack, I think. Let's see. Let me go into my list of things that I was going to tease to you. We're also adding another solar telescope in Chile, so the sun will be visible not only when it's sunlight in Canary Islands, but sunlight in Chile. So that means like 18 hours a day. I already told you about the chat and the video hosts. And there's also going to be a new kind of guide coming soon. So when you log into SLOOH in a couple of months, our special smart guides, you're going to get to pick from like one of 10 guides. And the guide is going to know what you've been doing, is going to know why you're here, and is going to help show you the coolest things that have been going on in the night sky since the last time you logged in. Arvin.
I have a question. So will these new telescopes which you're launching be like Canary 5 and you'll be able to see on the telescopes bar?
That's correct. They'll all be there. So we have 3 new telescopes coming online in about 6 months for tracking satellites. And those are from Chile and Australia and one in the United States. And that's actually in partnership with the University of Texas, right there in your backyard. University of Texas has one of the best astronomy and astrodynamics departments. So I hope some of you will wind up at University of Texas. And one of our very important members of our community, Dr. Mariba Jah, who's a professor there, he's going to be helping to develop the learning materials for tracking satellites. All right, we're about out of time. I just want to thank you all for your really great attention. Thank you for filling out our survey. Never stop using SLOOH and dreaming about space. We are all wishing the best for you, and we just want you to grow up and really appreciate the natural world around you and all its beauty. So I tell you, get off your computers, go outside, don't be afraid of the dark. Try your best some nights to go outside, leave your phone in your house. Don't turn on the flashlight on your phone. Don't spoil your night vision. And try to just appreciate how beautiful it is outside at night. There's really not that much to be afraid of. Some nights you can go out when the moon is full and have a great night. And some nights you go out when there's no moon and it's so dark, you have to wait like 20 minutes for your eyes to get adjusted to the darkness. And once, if you could be patient and just chill out and not go near any lights and don't look at lights, try to go to a ball field and lay on your back and look up at the stars and just find some peace in that and try to find some peace in the darkness. And I think you will, you'll open up a whole new environment for yourselves. And certainly at SLOOH, we don't want you to be glued to your computer all day. We want you to use SLOOH to learn about the night sky, and then we want you to go outside and find a way to explore it. All right, so it's Friday. Happy weekend, everybody. Thanks for so much. Thanks to Tyler again and Hanson. And take care of yourselves. And we'll see you on SLOOH.
Thank you so much. Thank you so much, Mr. Michael. This is Kathy. I'm Hanson's adult leader in the TTAS. We also have Kevin, our coach. Kevin, do you want to say a few words, Kevin? Hello, Coach Kevin. Are you there?
What does Kevin coach?
Yeah. Coach Kevin has been the adult leader for TTAS and JTAS in the past 6 years. You know,
Nice.
he's been volunteer a lot of his time and train our kids, share knowledge. He has a private observatory on his farm, and we go to his observatory all the time. Right. So without him, this community does not exist. So
I see.
yeah.
Well, thank you, Kevin. We appreciate it.
Yeah, Kevin, I'd stepped away for a second, so but I also want to point out that Hanson and Tyler have both done all the work in setting this up on our side and getting the presentations done and presenting the stuff, and they've just done a fantastic job getting this going. I've done very little, and just a real testament to them how well this has gone this week. So I want to give a big thanks to them. Yeah.
All right, thank you. Thank you, Kevin. And Hanson and Tyler, we talked about this SLOOH community yesterday, and we have idea that this summer camp is not stopping here, and we can start a SLOOH youth community today. So totally, we have 63 kids around the world sign up in the past 3 weeks, and 50% from Texas, and we have 5 from international, Greece, in Turkey and India, amazing, and some of kids from California, Georgia, you know, and other states of other states. So our proposal, if other kids online, if you like it, please click thumb up or clap and tell us you want to be part of this, and we're going to continue this activity. Maybe we can do it once a month online gathering. We got a SLOOH party once a month, starting from August or September. And Mr. Michael, we hope that we can have continuous support from you and Anna going forward.
Absolutely. You can count on us, and we welcome you into the community. And as I said, we're going to keep doing more star parties with the new capabilities. So we'll try to merge this into bigger community activities and just try to see each other as real people. And thank you for teeing all this up.
Sounds great. Hanson, Tyler, you have anything to add?
No, but thank you for your presentations and thank you for cooperating with us in order to set up this event.
Yeah, and thanks for your time and all the effort on your end to help get all this off the ground. So,
it's our pleasure.
Thank you guys so much. It's been such a pleasure. You're so fun to work with, and we'll keep working together. Have a great rest of the camp, everyone.
Bye, everybody.
Bye.
Bye.
Bye, Hampton.
Bye-bye.
Bye.
Bye-bye.
Yeah, all other kids will stay to continue, right, Tyler and
Yep.
Hanson?
We have a lot more events to go on next.
It's 2:05, so I believe it is time for a 5-minute break, right, Tyler?
Yeah, sure. We can do a 5-minute break.
All right, so we return in 5 minutes.
Can we do 10
Notebook in
minutes?
now.
Can we do 10 minutes?
For Eddie, I can run a quick Kahoot during this time for you guys.
You could make it 10 minutes.
No. I'm fine.
It's optional. It's optional, I guess. After this, we have some more presentations. So.
Yeah.
Cool.
And it's going to be very fun. Trust me.
Yeah.
I should have sent out the schedule already, but I'll post it again.
Yeah.
So this is the schedule.
Make sure to pin the schedule in the chat.
How do you do that?
You're a host. You should be able to pin it.
I'm a co-host, not a host.
Same thing.
You can do that.
It's your message. You should be able to pin it.
I don't know how.
Okay. Well.
Can you like?
Yes, Eddie. What do you need? I can.
I heard boss music playing in your background.
Look, I'll tell them on the camera. This is where I am right now. So I don't know why. How could there could be boss music here? So,
most likely, he's playing a game.
Is there no one there? Okay.
This is the College of Mechanical Engineering at UC Dallas.
Yeah. Yeah, I just heard something.
Hey, my sister goes to UT Dallas.
Nice. I don't know if I'm allowed to talk about my research, unfortunately, but it is fun.
I want to go to UT. I mean, not UT. I want to go to Ivy League.
Nice. Ivy Leagues are the best, obviously. So.
Oh, MIT. It's nice.
MIT's it's one of the options. There's others. Harvard, Purdue.
Yeah, MIT is like one of those schools where STEM is really good.
I want to go to Princeton mostly.
Princeton?
Yeah.
It's a good choice.
Some of the graduates from our club, we have one in MIT, one in Princeton, and
one at Harvard,
one in Yale.
Oh yeah, okay.
Yeah.
So.
Although Andrew is switching over to medicine, I think.
Okay. That's pretty good though, so since we have so many people here that do that. So if you guys want to go to a good college, maybe join the club, see for yourselves.
I'm part of KTEC already.
Nice. So if you guys are not local here in Texas, if you don't live in Texas, we do have resources to help get youth clubs set up in your area. So you could do that and start your own, help encourage other people to, take up astronomy as a hobby.
I should mention, Ramesh is going to A&M, Texas A&M, to study aerospace engineering. So, got about him.
My choices are either A&M or I go to UT Austin. Most likely A&M.
Most of our alumni actually.
A&M.
all of our alumni have gotten into an Ivy. Ramesh is just
Yeah.
going to A&M because it's like the best engineering program in the state and actually in the country.
Yeah, there's also like tuition just like the entire like fees like less than an Ivy League would because like Ivy Leagues like if you were to get in it's also like pretty expensive to afford it.
Yeah. And yeah, I should mention, yeah, Ramesh was accepted at two or three at several other universities, including Duke and others.
Yeah.
Duke and Purdue, and some
Like
other.
A&M's a pretty good place though. My sister goes there. Like I've been down there a couple times already.
Okay, 5 more minutes left on break.
In 4 minutes, we will go to the next presentation. Actually, this it's been enough time already. We can already go. You can go ahead and.
No, we can wait 4 minutes.
That's so long. It's, it's so time consuming. Oh, that would be so dreadful for me to do so much work for you guys.
Yeah, I just texted you and Hanson. You guys need to do a write-up on this for the Spectrum magazine. So
Yeah, we can do that. Should we also do one for the reflector or no?
that's not a bad idea. Yeah, make it for both.
Okay. Did the telescope one, did the what was the one? The how to create a astronomy club one get sent out yet or no?
I don't know. I'll have to look.
Okay.
I don't think it has.
Got
Uh,
it.
Now, did I make? I think you sent another copy, and I think I made some comments. Is that right? Or
Yeah.
okay.
I might have
Well,
I might
I
have
won't submit it. You
additions.
guys will need to submit that.
Okay.
Or, yeah, um, I would send it to Gary, and have him comment on it as well before you send it in.
Okay.
Gary?
Yeah, Gary.
Does he go by Sir Gary? Sir Gary?
No, he's not a doctor. He doesn't go to surgery.
Ah.
No, he's one of our the main task club members. He's our astronomical league. Uh, he's one of the uh, leaders of the astronomical league, and he's in our club. So when we send stuff to the astronomical league, we usually go through him. Are you guys familiar with the astronomical league? While we're waiting, I can give a quick rundown.
Uh,
So
you, you should
if
go
you,
ahead and give a quick rundown, I believe.
yeah, let's do it real quick, just a minute or so. So if you belong to a club like Team Task or JTAS, who actually are members of TASK, you are also a member of the Astronomical League. The Astronomical League is the kind of the governing body for all the big clubs in the U.S. So they have a lot of awards that they give out. Several of our members, both um, uh, both Tyler and Hanson have won Astronomical League awards, as well as the John Wagner Award at the Texas Star Party. But they also have observing programs. So, for instance, they have the Messier program where you have to go out and observe all the Messier objects. Then you get a pin and a certificate and all that other stuff. But all in all, the Astronomical League has a lot of stuff going on, and you need to be aware of it if you're in astronomy, especially if you're a member of the club and our club, because once again, they do several major awards for youth every year. So my plan is one of these years to have Team Task and J-Task win every one of the awards that they give out for the youth. But that came close this year, but not quite.
Coach Kevin,
Yeah.
one time I signed up for the Astronomical League for literature, and I wrote about Galileo Galilei.
Yeah, I thought that was a good one. Yeah. I
I
think,
didn't win.
unfortunately, I think that's the year you were up against Amelia. I think Amelia won that year. So
Oh,
yeah, but you should keep trying. Yeah, I like your write-ups when you send them in. So keep trying to do that.
You were only beat by seniority. Is the
Yeah,
main thing. Us slightly older high schoolers have a big advantage over you.
yeah. One thing I found on those awards is to make it a little personal. In other words, don't just write about Galileo, but explain why Galileo is important to you and why knowing about Galileo is important and things like that. So if you make it a little more personal, I think it's a lot better. That's
okay.
what Amelia did, and she did really well. So,
Okay.
but I think one of these days you're going to win one of these awards. I can almost guarantee it. So, probably in another year or two, we need to start putting you in for the John Wagner Award at the Texas Star Party.
Oh.
Okay, I guess about time for you to start talking about the party, right, Tyler? Oh, Tyler, go away.
Oh yeah, what time is the party on tomorrow?
Well,
Well,
that's what we're talking about next.
Okay.
Lucky for us. So,
take it away, Tyler.
Yeah. Pulling up the presentation right now.
How many of you are in the Dallas, Texas area?
I'm in
I'm in the
Houston.
Texas area.
I'm in Houston.
Same with me. I'm
Okay.
in Irving.
Okay, yeah, Irving's close enough.
am South Lake.
Okay, South Lake's real close to where the party is. Yeah.
I live in Melissa.
What'd you say, where?
Melissa by
Oh,
McKinney.
okay. Yep.
That's slightly farther. It's still reachable.
That's just north of me in Princeton, so
Mhm.
it's up the road a ways.
It's not northern Greece.
Yeah, northern Greece would be hard to come to the party.
I live with my sister Sabrina.
Ah.
She's in South Lake.
Oh, cool. Okay, so I'll go ahead and talk about this stuff. So the start party will be from 9 to 10:30 p.m. Central Time at Frisco Commons. We'll also be on Zoom still. Basically display how to use telescopes and stuff. So Frisco Starfest, this is basic information on the star party that we're going to. So the Frisco Starfest is hosted by the Texas Astronomical Society of Dallas. So it usually happens on the second Saturday of the month from 6 p.m. to 10:30 at the Frisco Commons Park in McKinney, actually in Frisco. More info will be sent out later. I will send out more information after this camp once I finally get confirmation from task observing on what's happening there. So, what is TAS? I presented this yesterday if you already heard, but most of you missed it because I presented it at the very end. So, what is TAS? TAS, or the Texas Astronomical Society of Dallas, is an organization that's based in Texas that features monthly meetings at the University of Texas at Dallas. It also has a dark site in Atoka, Oklahoma that's free to its members. So, what are the groups of TAS? Two subgroups of JTAS exist. JTAS is the younger age group, running from 1st to 7th grade, 7 to 12 years old. TTAS, Teen TAS, is the older age group, from 8th to 12th, 13 to 18th years old. TAS membership is required to join JTAS, which is basically you or your parents pay a $60 fee, and then any other family member only needs $5. And then after that, it's really just age to join. So what do T-Test and J-Test do? J-Test is mainly for children to learn about the stars, have fun, and learn how to use telescopes in general. Though if you already know a lot about that, like Shri, this is where you can start to present at meetings, do a bit of research, and get into physics. Also, T-Test and J-Test are currently getting a $40,000 remote research observatory for use by any member. We just need to put the roof on. So this is how to join JTAS and TTAS. In order to join JTAS or TTAS, there's a $60 membership fee that needs to be paid to the Texas Astronomical Society of Dallas. After that, you need to fill out a Google form in order to be put on our email list so that we can inform you about meetings. In fact, I believe they already sent out the Google form. All that's needed is just to fill out this. So once you go here, it's just fill out your information, and the Google form looks like this. Additionally, I will post this again in a camp recap email. This text.
Yeah, by the way, yeah. It's real important to do that Google form. A lot of people join the task, but that only gets you into our main group. But to really get into JTAS or Teen Test, you have to fill out that Google form so we know about it.
Yeah, so that way we can get you on our email list. So this is the thing that me and Hanson are working on right now. We created this really recently. So here's the Discord link for anybody that hasn't checked it out yet. So what we're doing is, since this camp features so many international students, we're trying to create a organization that helps connect U.S. students and international students to research to help further their learning of astronomy in general. Like, for example, this summer camp is an example with SLOOH. Also, we're going to have speakers eventually when we get enough members. So, how are we going to do this is that we're going to run this through Discord right now, and it's really just in beta right now. So, yeah, that's this so far. Next up on our presentation list is Hansen and classification in astronomy. You got it, Hansen?
The issue is I'm kind of busy right now. I'm still working on our video. Um, could you do yours first and then I go after, or is like?
Yeah, I can do my presentation first.
Yeah, you can just do yours first, I guess.
Okay,
Sorry.
so never mind. We are doing a formation of the solar system. Again, I will post all these presentations later for anybody to use. So, welcome to the solar system. This presentation is literally just about the formation of the solar system. So, as as our learning objectives for today, what properties of the solar system must a formation theory explain? Do none of you guys know this? It's like you don't know how to write scientific theories or hypothesis.
Bro.
Okay, I believe everybody knows this then. How about what theory best explains the features of our solar system? How about that one? Does anybody not know any theories on how the solar system formed?
The Big Bang.
That was how the universe formed.
So basically, basically like we have a big cloud of dust which collapsed inwards and made the sun. and after that, we had a whole bunch of other accretion, which formed a whole bunch of chunks of rock that later
crashed into each other to
they
make
clumped together,
planet.
and then sometimes they crashed into each other.
And they made
then
planet.
a few billion more years of chaos, and then after that, we have like the current solar system.
That is basically it. So yeah. Next slide. So, what properties of our solar system must a formation theory explain? So, patterns of motions, existence of two types of planets, terrestrial and Jovian, existence of smaller bodies, and notable exceptions to unusual patterns, like the rotation of Uranus, which is on its side, and Earth's giant moon. So, does anybody know the difference between terrestrial and Jovian? And no searching this up, please, Alex.
No, I don't know.
I'm not searching it up.
I think I know what terrestrial means.
Terrestrial, basically,
I don't know
like,
what it is.
it's basically just a spherical chunk of rock, and then Jovian planets are like gas, chunks of gas, and other things.
That is true, I believe. So, what theory best explains the solar system? There's one major theory, which is the nebular theory, states that our solar system formed from the gravitational collapse of a giant interstellar cloud, the solar nebula. Nebular is the Latin word for cloud, and caught in lost space. Forgive if I mispronounce those names. Proposed the nebular hypothesis over 2 centuries ago. So, another idea or another hypothesis is that the planets formed from debris torn off by the sun by a close encounter with another star, but this cannot explain the gravitational orbits that most planets have today. So this is what we have. We know about the two theories now. So next slide. So where did the solar system come from? We just covered this.
The giant collapse of
Basically,
a
we have
giant
this
cloud,
nebula which collapsed inwards on it.
which created a lot of chaos, and planets got created by asteroids crashing into each other, and that's basically it.
That is correct. There's not much else I can say there. So, what caused the orderly patterns of motion in our solar system? Basically, what caused the solar system to rotate like that is what this is asking. Have these rotations of planets. Does anybody know?
This is a guess, but I think it's gravity.
George, do you have an answer?
Yeah, when it was when it was a big star, a nebula, and the solar system collapsed, the law of angular conservation came into effect and made so that the objects that were created continued spinning in the same direction the nebula was spinning.
That is mostly correct. So, where did the solar system come from? So, basically, how it was formed is that elements from planets were made in stars and recycled through interstellar space. In fact, we talked about this a few days ago, in fact, SLOOH talked about this a few days ago, where they said that it would take 6 supernova or the life cycles of stars in order to create all the material we have today. So, evidence from other glass clouds, we can see stars forming, leading us to support the nebular theory. We don't really have any support for any other theories. So, this is the main important question about this. So, what caused the orderly patterns of motion to form in our solar system? So, how this happened is that the rotation. Well, does anybody remember what the conservation of angular motion is? We talked about this in our neutron star presentation. George?
When something spins in space, it does one stop spin.
That is correct. So basically, as more mass comes in, then object moves faster, is basically what this is saying. Kind of like a ice skater moving in its arms while spinning. So as the rotation speeded up, slowly and slowly, it flattened into a disk. Does anybody know why it flattens into a disk? George?
Because when it is rotating, what was it called? And the force is it is just force sideways on its center, and it spreads out. So I don't remember the term. The term. Mm. It's the
Kind.
same reason the Earth is not completely a sphere, but I don't remember the term.
Hmm. Kind of, but not entirely true. The main reason is that because it has up and down motions that are caused by collision between particles, so it can't really go up or down, so it flattens into a disk in either direction. Eddie, do you have something to say?
Yeah. Can you like email us the star party information?
Yeah, I can definitely just email it.
Yeah. Email the star party
Yeah. Actually,
information.
Hanson, can you do that right now?
Gimme. Alright, thank you.
Okay. So collisions in between gas particles and cloud gradually reduce random motions. Basically, what I was talking about before, where particles would fly out everywhere because of the electron degeneracy pressure. So, and the collision between gas particles would also reduce up and down motions because they would lose energy. So it would slowly flatten and shrink. So basically, that's that. So here's some other disks around stars, some examples. So what we have learned is that disks form around stars because of angular motion and collision between gas particles. So where did the solar system form from? Most of us already know this. Galactic recycling built from elements from which planets formed. So the formation of planets. So why are there two types of planets? Can anybody explain this?
Why not?
So basically, like the rocky stuff didn't get blown off to the edge of the solar system, and then it coalesced together.
Kind of. Does anybody know the exact definitions between the differences between Jovian and terrestrial planets? Actually, we could just answer those in the next few questions. How did terrestrial planets form? What do you guys think?
When asteroids collide into each other, they like that I think they formed like rocky like shapes which created planets. I'm not actually sure.
Kind of. George? How about you?
The solid matter from the solar system basically came together and became a planet.
Kind of too. How about Jovian planets? How did they form? Does nobody know how gassy planets formed? Or gas giants?
So basically, like all of the light elements got thrown out to the edge of the universe, to the edge of the solar system, where they like coalesced together into gas giants.
Hmm. Now, I have another question. What ended the era of planet formation? Like, why don't we see any more planets that come out? Like,
Basically, like all of them coalesced together and formed stable orbits.
what about places in the Oort cloud?
And they kind of ran out of work cloud stuff.
Uh,
Like not really.
okay, then we'll go ahead and talk about this next. So, why there are two types of planets? So, I'll go ahead and explain this before we go on to the next slides that will confirm this. So, basically, why there are two types of planets is that originally terrestrial planets in the solar system were rocky planets. I'll just say that. So, rocky planets were formed mostly of rock due to them having a weaker core or smaller core due to them being below the frost line. Does anybody know what the frost line is in this scenario? We'll talk about this in a bit.
Basically, the boundary where water starts to freeze.
That is correct. So basically, why there are gas giants outside of the frost line is that because ice is a heavy material and increased gravity, hence pulling hydrogen and helium into the planets, creating a sort of a gas giant. And as more and more gas congregated, it originally created gas giant storms and stuff. So that's basically why there are two types of planets. Does anybody have any question about that before I go on to the next slides? Okay, then I will continue. So, conservation energy. As gravity causes clouds to contract, it heats up. Most of us know this. Honest if nobody understands this. So the inner parts of planets are hotter, and the rocks can be solid at much higher temperatures than ice, hence being closer to the sun. So inside of the frost line is too hot for hydrogenated compounds to form ices, and outside of the frost line, it's cold enough for ices to form, hence creating all these other planets. And how did terrestrial planets form? Small particles of rock and metal were present inside the frost line, which originally collided due to gravity and assembled terrestrial planets. So yeah, here's like an simulation example. So this process is called accretion. Not much else there. It's just a little fact. It's kind of similar to accretion of planets. It's just gravity pulling in objects again. So how did the gas giants form or Jovian planets? So ice could also form small particles outside the frost line. So larger planets and planets. Larger planetesimals and planets were able to form, and gravity of these larger planets were able to draw in surrounding helium and hydrogen gases. So the gravity, rock, and ice in Jovian planets drew this in, like I just stated before. Does anybody have any questions so far? Or no? Okay, then I'll keep going. So what ended the era of planet formation? Why are there like no more planets outside of the Oort cloud when there's a lot of material there? So basically, it was because of a bunch of solar wind that blasted out because of the lack of gas, and it blew away all the leftover gases away from the solar system. So that's why you don't see a lot of gas around us. So this is a theory where the young sun was spinning much faster now due to its heat and because of angular motion. Well, the conservation of angular motion, where the more material it absorbs, the faster it spins. So the friction between solar magnetic field and the solar nebula wind probably showed that more areas were able to suck while the other areas were unable to, were left out. Hence why there's a gap here. So this is what I've learned so far. Does anybody have any questions before I go on? Really? You guys all understand this? I must be a good teacher then. Okay, then we'll keep going then.
Wait, so that means if you guys all understand this, then you guys will do awesome on the multiple choice quiz we have at the end of this. So.
What?
Oh, yeah. Well, it's gonna be a booklet.
No. There's a booklet and there's a multiple choice quiz.
No, that's just trivia.
No, like this is gonna be like extremely difficult.
Okay, Hans is making a extremely difficult multiple choice quiz after this. So yeah. So this is also we have also learned about planet formation and stuff. So the aftermath of a planet formation. Where did asteroids and comets come from? Why is there an asteroid belt? How do we explain exceptions of the rules? Actually, I will ask these questions to you right now. Where did asteroids and comets come from? Can you guys give me an answer?
The Oort cloud.
Kinda not. George?
Aren't they the remnants? If we're talking about the asteroids and comets from inside the solar systems, I guess they are the remnants of the nebula. Outside, I don't know.
So, why there are so many asteroids is because the it formed during the solar system original creation, hence the asteroid belt. And then outside the solar system, it was simply too far away for the sun to be able to pull them in. So, how do you explain exceptions to the rules? Like, for example, dwarf planets is what this is going to talk about here. And then, how do you explain the existence of Earth's moon? Because it's one fourth the size of the Earth. And was our solar system destined to be? Was it supposed to be created like this? So, where did asteroids and comets come from? Most of you have already answered this. I'll go ahead and explain this. So, left over from the accretion process, rocky asteroids inside the frost line, and icy comets outside the frost line. Hence, also why the asteroid belt is also called the frost line. So, how to explain these exceptions to the rules, like Uranus' odd 12 tilt and Earth's relatively large moon. So, heavy bombardment left over from asteroids or planetesimals. Does anybody know the definition of planetesimals before I keep
Small
explaining?
planets, basically. And look at the planet and like look at the small planet in the distance in this image. There's like the circular crater on it.
Yep. So basically, these are small planets that didn't fully form and then smacked into others. So basically, they are late stage forming planets that smash into other things. So the origins of Earth water, this is coming from icy planetesimals or asteroids or comets. Basically, that's the theory behind that. And then the capture. Does anybody have any questions so far? Or okay, I'll keep going. So captured moons, aka Phobos and Deimos here, may have been captured planetesimals. And then how do we explain the existence of the Earth moon? Does anybody have an answer to this?
Basically, this giant planetesimal crashed into Earth like a few billion years ago.
Its name was Thea.
Yeah, and then basically it sent out a whole lot of debris that turned into a ring and later coalesced into the moon.
True. What about you, George?
Yeah, but since that's just a theory, another theory is that it was just a small planet moon that was then uh, captured into Earth's orbit. We don't really know for sure.
That is correct. So basically, it was a giant impact of Delta Dionys, stripped matter from Earth, and then caused it to become the moon. The reason why Uranus has an odd rotation is because of giant impacts. Our Earth is also on a tilt because of the Earth Moon impact. So, was our solar system destined to be? The formations of planets in the solar system nebula seems inevitable, but the details of individual planets could have been very different depending on the materials or the different conditions. So, this is what we have learned. Where did asteroids and comets come from? They are leftover planetesimals, according to the new nebular theory. And how do we explain exceptions to the rules? So, the bombardment of newly formed planets by planetesimals may explain these exceptions. And how do we explain the existence of Earth's moons? So, material torn from the Earth's crust by a giant impact formed the moon, or a giant moon object smacked into the Earth. And was our solar system destined to be? It was. Formation of the planet was inevitable, but characteristics such as amount of water or the amount of dust on Venus could have been very different. So, the age of the solar system. How does radioactivity reveal an age, aka carbon dating? How does that work? And then, here, we'll go ahead and ask this question. How does radioactivity reveal an object's age? Explain the process. George?
Radioactivity, because a radioactive object has something called a half-life, where in half the amount of time it will exist, some radioactive isotopes will get released, and thus, with the amount of radioactive isotopes remaining, we can determine the amount of time it has passed since its formation.
I could have answered it better right there. That's a perfect answer. And then, when did the planets form? This is more of a factual question. Does anybody know?
4.6 billion years ago.
That is correct. Good job. So, how does radioactivity go on objects age? Just like George said, because of radioactive decay, half-life is the time the nuclei in a substance takes for half the nuclei in a substance to decay. Some isotopes also decay into the other nuclei. So this is basically everything that George said. So when did planets form? Radiometric dating or carbon dating tells us that the oldest moon rocks are 4.4 billion years old. The oldest meteorites are 4.5 billion years old, and planets probably formed about 4.5 billion years ago. That's that. So what have we learned? Radioactivity reveals an object's age, and planets formed about 4.5 years ago. So that is the end of this presentation. Does anybody have any questions? That is a good point through radioactive decay cycles. No questions? Wow, you guys must have really understood my presentation right here. I'm awed by your participation. William?
Do you know some applications other than the ones in the presentation of radioactivity and like just the isotopes?
So what is your like applications of carbon dating or radioactive decay and stuff like that?
Yeah.
Well, for archaeology, for example, you can see how old objects are. For example, the Egyptians, you can see how what time in time they were, what time they existed. George?
If I may, we can also detect the different layers of the Earth structure to see more like the geological history of the Earth using radioactive dating and carbon dating.
That is true. Who's gonna speak? Who did I accidentally cut off? Well, is there any other questions? If not, then I'll go ahead and put on the booklet then. Stress your knowledge. I'll find a Kahoot for you later, Eddie.
What's the code?
I'm pulling it up right now.
What's the game mode?
I have not made it, not opened it up yet. Okay, this booklet was made for a different presentation, not this one, but I didn't want to make another
Oh
one,
no.
so yeah.
So
Okay,
it's
actually
gonna
that's
be
the
off
host ID. That's
topic.
the wrong thing I posted. Don't question
Oh,
that.
okay.
My bad.
Dang it.
Okay. So, this is the booklet. What game mode do you guys want?
Classic.
Monster
I'll do it if
Brawl.
it's classic. I'll do if it's
Deceptive
classic.
Monster Bros.
Dude,
Monster
Deceptive dinos.
Deceptive dinos. Deceptive
Monster
dinos.
Brawl. Monster Brawl.
Deceptive dinos.
Monster
Deceptive
Brawl.
dinos.
Deceptive
Monster Brawl.
dinos.
Monster Brawl.
Deceptive dinos.
Monster
Deceptive
Brawl.
dinos.
We'll do Monster Brawl next time in the future in a time far, far away.
In like a
Wow.
year.
Don't worry, Hanson will do Monster Brawl, right, Hanson? Right, Hanson?
Perhaps.
Hanson.
Right, Hanson?
Perhaps.
Okay.
Perhaps. We will see.
Perhaps.
No.
Okay,
What is the
so
code?
it is
I need a link.
240607.
What? What'd you say?
I need a link.
240607.
Yeah.
Please put your real names.
Guys, someone put their name as Eddie Lee for me.
Eddie.
I'm
If you
not
don't
doing
put
it.
your real name-
William, put me as Eddie
If you
Lee.
don't put your real name and you win, then you won't get credit.
That's fine.
Okay. But can you guys at least tell who I am?
240607.
What
Smalls.
40607.
Do I have to put my real name? Hello?
Yo. Ness.
Who's the anaconda? I'm always the anaconda.
Okay, we will start in
3, 2, 1.
not in just in time. We will start in whenever. Is everybody in?
Maybe. I'm in.
Maybe.
Okay, then we'll start now.
Who's the anaconda?
The anaconda is no one. There is no anaconda.
But it's on the thing it said someone was the anaconda.
I think you were looking at Alexander or Arav. We don't have an anaconda here.
As it revolves around another object.
It's missing.
As it revolves around another object.
Guys, I cheated.
Oh no, he's cheating. Bro, Weddy Jow is crazy.
Yes, I caught.
Oh
What?
yeah, Rob, you caught me. You stole 9 fossils. Good job.
That's crazy. Is a strat just to always cheat?
No, that's not the strat.
That's not the strat.
The strat is to always cheat. I cheated. The strat is to get lucky, guys. Oh yeah, good job, Sri. You stole 12 fossils.
David.
Wait,
Cheated.
Sir Weddy Jow, how many fossils do you have?
I have 12.
I caught.
Stop cheating. Stop cheating.
Never mind, I have 1,000.
Bro, what's this question? The name of the class gecko.
The name of the question is.
The name of the class gecko, what is that?
I'm stealing from Wesley.
Guys, I cheated.
He's not. He hasn't cheated yet, bro.
Oh no, he didn't cheat.
yeah. Wait, actually, that's really brilliant to say I cheated.
I did cheat.
Crazy. Bro, he's not cheating, bro. Why are you investigating? Oh, dang. 2 times in a row.
Jason.
Hamilton.
Guys, I cheated.
Wesley cheated.
Excuse me, Triple T.
Why
you
is your
just
question
cheated.
called the name of a class gecko is?
Don't worry about that. I put
Because
that
this
there.
was made for a different thing. We do not have a class gecko, sadly. You can go ask Hanson for one. He might have one.
Yeah, Hanson, where is it? How did I hit it? Guys, I cheated.
Bro, he hasn't cheated. 3 of y'all investigated. 5 of y'all investigated him and got nothing. Bro, William.
I'm just too good, you know?
Rumor is that the class gecko.
What is
Oh, Wesley, you
this?
cheater.
What is this? It says what is Friday? French fried Friday, frozen fridge
Fist bump Friday. I got that right. It's fist bump.
Wait, guys, don't tell
French
each other the
fries.
answer.
It's fist bump. Deuce fist
Bro,
bump.
Jason.
Thank you, Justin. Thank you.
You see,
Guys, I
those questions
cheated.
are all skill questions. You guys have to have skill in order to.
Jason, you cheater.
Guys, I cheated.
Crazy.
We all know you cheated.
If I did it. Why are y'all investigating me? I didn't do anything.
I'm investigating Triple T.
Triple T probably did something. He just shot up by so much.
They love you.
Check in.
Check-in jockey. It's a check-in jockey.
No, it's brain rot.
Wesley is a cheater.
No, Wesley is a check-in jockey.
Wesley is like a cheater.
A check-in jockey.
No, a check-in
He's
jockey.
a checker. He's a checker.
It's a check-in jockey. A check-in jockey.
Guys, I'm such a big
A
cheater.
check and junk key.
And John check-in.
Wesley, the check-in jockey.
Check-in jockey.
Comma is a cheater. Comma is a cheater.
Comma.
Wow, is Weddy Zhao cheating? 155K is no joke compared to the second place, which is 44.9.
Yeah, but you know the funny thing is, like 5 people investigated last time, and yeah, nothing happened.
Yeah, I'm literally not cheating.
What is the name of the class gecko?
It's actually
It's Larry.
Samantha. It's Samantha.
Thank you, Alexander.
It's Paul.
Thank you.
It's Pog.
Samantha Quattlebaum.
Guys, I'm cheating. I'm cheating.
It's Sir Quacks a lot.
William, be quiet. Stop saying I'm cheating.
But I am.
Yeah, he is.
Then why would they tell it to everybody?
I don't know. So you
Bro,
guys are not investigating me.
Arav, use your brain.
Arav, it's called reverse psychology. Well, look, someone investigated me. I didn't cheat. Why are you guys thinking like that?
Whippy.
Yo, good job.
Arav, why'd you investigate me?
Because there's nobody else. Duh.
Yeah, but I have not cheated a single time.
Wow, is Weddy Zhao cheating? He's at 392. He's 3 times the second place.
Yeah, I think he's probably cheating.
He's
4
not.
times the third place.
I
and
never cheat.
nearly 10 times the fourth place.
Oh, never mind.
Y'all, I never cheat.
Arav.
Why are y'all investigating me? I'm not a cheater. Okay, peculiar.
If you investigate William, you'll lose.
Yeah, you will never catch me cheating. Oh, look, now I am so far ahead. Actually, never mind. Triple T is catching up.
Who's Triple T?
I do not know. But they won't get any credits if they win. So it's fine.
Winking brains.
Eddie, I'm gonna send you something. Don't leak it.
What? Just chose a random answer for me.
Yourself.
I didn't click anything.
Probably you didn't know you clicked.
Eddie, do you see
I
the
did.
message?
I think this was a kid and he did it for his whole class because he probably has a class pet and for his cafeteria lunch or I mean not his cafeteria lunch on Friday they always do fist
Hey
bumps.
guys, why'd y'all stop investigating me?
Hey guys, don't be dumb.
Oh, wait.
Elon Musk is located between the
Really,
inner and outer planets. What is this?
He's located in the inner, I think.
Yeah, I think Elon Musk is located in the inner planet.
Because he lives on Earth and Earth is in the inner planet.
Hmm.
No,
And
Elon
then
Musk.
he'll go to Mars, and Mars is in the inner planets.
As well.
Very well.
Okay.
Why are y'all still investigating me?
Yeah, guys, why are you investigating William when he literally said he's not cheating?
They want to catch me off guard, but I'm not gonna do it.
Bro, Shri, why are you investigating everybody?
Shri,
Shri is not
That's
getting
because
anything
he's a
himself.
cheater.
Oh yeah,
Yes, Shri?
investigate Shri. Get him.
Investigate Shri.
Yeah, get Shri. He's probably cheating.
Yeah, Shri's probably cheating.
Y'all can test it.
Yo, Jason's a
Only
cheater.
4% can be investigated, so and there's like so many people playing.
Nope, I checked he's clear.
Has anybody investigated Shri yet?
I'm host.
Yeah, I checked he's clear.
Shri is clear. Dang. Okay.
Update, I checked again, he's still clear.
Shri, let us know when you want to start cheating.
Is Shri too
Yeah,
embarrassed
I'm gonna
to
start to cheat
speak?
now. I'm gonna start cheating now.
Okay, Shri said he's gonna start cheating. Investigate him again.
Just investigate him once. Because he could be like William.
Come on. Triple T.
Bro, triple T. Triple T is
Who's
like double
who's
of
tongue?
blast. Weddy is
Unsurprisingly,
double
Triple
of
T is the
comma.
ultimate cheater with over 2 times the amount of second place.
And but the Weddy is also 2 times the amount for comma.
All of you are cheaters then.
Cosmos.
Yeah, comma was cheating. I caught him cheating a couple.
Oh yeah, Jason was a cheater. Triple T was cheating for like nearly half the game.
And comma
The
was
best thing
cheating
is
for.
not to cheat every single time, guys.
Weddy is
It's
also a
not
cheater.
necessary.
No, I tried cheating once and I got like bombarded with investigations.
Okay, so now we'll do something fun. We'll have a quick trivia break.
Bro, I don't want trivia. I want to play Blicket again. Or Gimkit.
Gimkit.
No!
And then after that, Hanson will present his very, very cool
Uninteresting
presentation.
presentation.
Very, let's see.
Very, very
Very
incentivizing. It's a very incentivizing
Let me just
presentation.
say this presentation, the next one, I've designed it so that at the very end you have to answer trivia questions. And if you don't, then you get a 0.
But you didn't make the presentation. I made it.
Yeah, I know, but like I added questions at the end. So you guys better be paying attention, make sure to ask plenty of questions because you don't know what's gonna come up on the trivia after.
Can I go to the bathroom before we start?
Yeah, sure. This is like your break right now.
Finger dash.
Okay, who wants to spin the wheel?
Who wants to spin the wheel?
Me.
I'll give you gravity points, hopefully. I got an Anna too.
Me.
Give everybody in the class 100 free gravity points.
Okay,
I
Eddie,
raised my
raise
hand
your
first.
hand
I raised my hand first.
Me.
Yeah.
Eddie
I'm so
first.
good.
Eddie, you got light. If we missed all the colors together,
White.
that is correct.
Easy.
No, that is not how you. Okay, this is the
Wait,
bug.
what?
Yeah.
What is
It
this?
is.
What
It
is
is.
it doing?
It is light. No, it is white. So Alex, your turn.
Hurrah.
Oh, that's the same thing again.
LOL.
Oh,
Does it always land on light?
I think it bugged. It's not supposed to do that.
Wait, this is really easy. I thought Hanson said it was gonna be hard.
Oh, this is the trivia I made. Okay, so that's
Yeah, I
bugged
don't have
out.
time to pull up the one I made, so you guys are lucky this time.
So this one's bugged out. Here, I'll just randomly choose questions from this one then.
Alright.
Well, you should have just used like the spin the wheel website.
Yeah, but this is cool. Okay, so mystery. How many satellites there are?
Put in a hint here.
650,000 maybe. I don't know. Is it 6 million?
650,000?
65.
Yeah, 650,000.
650,000.
650,000.
That's
Thousand?
Alex's point.
What is
That's
thousand?
Alex's point. That's Alex's point. Alright.
Yeah, there are no answers to this one. This one's bugged.
Why am I hearing popping noises?
Don't
Okay,
worry
that is
about it.
correct. Hopefully.
It's called hydraulics.
Which is not a force on a plane.
Yeah, Alex, put your hand down, Alex. Put your hand down.
Alex or
Good.
Sabrina, can you answer this?
Come on. Hint. F equals PV. That's your hint.
Can you double check that?
Bro, F equals PV is your hint.
I don't think they understand what that means.
Mass? Is it mass?
What?
Is it mass?
No.
No, Sabrina's the one answering, Arav.
Oh, my bad.
Bro,
Don't steal the little girls.
stealing is not allowed.
Got this.
What just happened?
Okay,
Okay.
so I guess we'll go to the next question then.
Salmon
I guess she got it wrong.
What is the most expensive?
She didn't even answer, I think.
It has something to do with planes in space. This is old, so even if the answers
Oh,
were
it's
here,
old.
this accurate.
Okay.
So what is the most expensive space project?
Alpha.
Hint, it has something to do with SpaceX, I believe.
Oh no.
Who is the CEO of SpaceX?
Actually, the most expensive space project is the ISS.
Come on, George. Come on, George. Come on, George. You got this.
Elon Musk is the CEO of SpaceX.
Alright, shush.
If you
The
didn't
space shuttle. The space shuttle.
Space station. It's the
There's no
ISS.
steal.
Well,
There's no
it said
steal.
it
There's
had
no
Is
something
steal.
George
to do
an
with
adult or
like
is he a kid?
Okay.
Is George an
George,
adult?
put your hand down. George,
Is
put your
George
hand
an
down,
adult?
please.
George is a very wise person in Greece that knows a lot about astronomy.
No. Is he an
George,
adult or is he a
please
kid? Is George an
I'm
adult or a
only
kid?
17.
What?
I'm only
He's only
17, don't worry.
17. He's only 17.
He's a junior. There's a lot of people that are junior in this.
Alright, George,
There's
please
like 10.
lower your hand. Yeah.
George
What is the
sounds like an
equator in
adult.
Arizona called? Who wants to answer this one?
That's Williams. That's Williams.
William, do you want to answer? William, turn on your microphone.
I thought it was on. Is it the Beringer crater?
I believe so.
No.
No?
No, bro.
No?
Arav is probably trolling.
I'm not trolling. I
Bro,
know
why are you
don't
smiling
troll
like
people.
that? Why are you smiling like that?
I would trust William over Arav because William
Yeah.
is older and has seniority.
Oh, and
Wrong.
also Rob just comments on everything, so you know what?
Eddie,
It's a Rob in third grade.
answer this next question.
Arav,
Actually, which one
are
do you
you
want to
third grade?
click? Which one do you guys
What?
want me to click? No worries.
Click on, the sun. Click on the sun. Oh.
Mercury. Wait.
Bro, what? That's wrong.
It is
That's
not
wrong.
Mercury.
Where'd you get Mercury from?
I think I forgot.
It starts with an alpha.
I didn't need to answer choices.
Eddie, do you know this one?
Can it steal?
Sure. Eddie.
I think
It's
Proxima
either
Centauri?
Alpha Centauri or
Proxima
Proxima
Centauri?
Centauri. It's either Alpha
Bro,
Centauri
Alex,
or Proxima
Alex,
Centauri,
why'd you
depending on
steal?
which star you want to see.
Oh my god. Bro,
Alpha Centauri
Alex,
is like the entire
I'm the one
purple star
answering.
system.
I'm the one answering. I'm the one answering here.
So let's
I'm
not
the one
argue
answering
over
here.
this, okay?
I'm the one.
Please calm down. Please calm
Okay, Eddie, answer.
Yeah, Proxima Centauri.
That's my.
Yeah. I believe it's that.
How much gravity points per question?
You're gonna have to ask Anna that.
Okay. So, yay, 2 questions.
Okay, so that will be it for the Wheel of Fortune. I'll see if I can get this to actually work in the future.
Proxima Centauri.
And then now, please clap your hands for Hanson's inspiring presentation on classification in astronomy.
Okay, guys, so let's pull up this presentation. All right. Do you guys see it?
No.
Give me a second. It's lagging a bit on my end. You guys see it now?
No.
Bro. Okay, now.
Yes.
There we go, finally. Okay, so today we'll be talking about classification in astronomy. So this is a pretty cool topic. So this is a pretty important topic as well. So who here thinks that classifying stuff is important? Just raise your hand. Good. Okay, so let's talk about how we do that in astronomy. So obviously this is not any presentation without some nice advertisement for some nice books, so I recommend you get those. So here's what we're going to be talking about today. So we're going to talk about why this is important in general, then we'll move on to specifically astronomy, and then how astronomy is specifically classified. So Let's go. So in history, as you probably learned from the history of astronomy, so most classifications of celestial objects are based on their actual physical nature. So whether it's a planet, star, or something. And since astronomy has been existing for so long, initial classifications may just not really be like useful. So there's that. And then we also have a class status, which is determined in this classification system. So this is a little quote that was pulled. So this shows how important classification is in science. But first of all, Arav, you have a question?
Oh no, I was raising my hand for before. I just forgot to.
Yeah, it's fine. Okay. So this specific part, I just want to highlight that this notion consists in having a true idea of the objects. So if you want to know how to do stuff, so like science, you want to know science, you have to actually know what the objects you're studying are, and they're distinguished by classifying them and giving them the appropriate names. So like, how would you study an apple if you didn't know it was an apple, for example? So this is from 1735, so it's very deep stuff.
Oh, you just name
This
it.
also shows how important classification is in general, because the classifier of an unknown subject. So if you just newly discover something, it begins with how to choose the parameters based on what the object does. So you skip these; that was not needed. So a good fair example of classification is this thing. So who knows what this is? It's already written on there, but
It's the periodic table.
yeah. So this is a way to classify elements. So the periodic table is one used classification methods in the scientific world. And then what about this thing? Has anyone seen this one before?
No.
No? But you'll get to this soon. This is in quantum mechanics and stuff. So this is the standard model of particle physics. So we have this is essentially just where all the particles are. So each one of these is classified based on some parameters like spin, mass, and charge or something. So that's some ways to classify it. And then in biology, let's move on to that. So we have the 5 kingdoms. So we have, who here can name the 5 kingdoms of biology? Just raise your hand.
Me.
Okay, and can you name the 5 kingdoms?
Hopefully. Animals.
Yes.
Flora.
Yep.
Fungi.
Yep, that's 3.
Microbes.
Yeah. Well, actually, wait, depends.
Wait. Hold on.
Okay, well, I'll just go. So we have.
If it's not microbes, then what's it called?
So we have animals, plants, fungi, bacteria, and protocysts. So these are technically microorganisms along with fungi. So that's the 5 kingdoms. Everything can be split down into this and then further refined. And then we also have the 3 domains of biology. So I would ask what they are, but too late. So we have eukaryotes, we have archaeobacteria, and eubacteria. So this is just this is microbes pretty much. So. And then obviously in astronomy we have classification here as well. So there's classifications for planets, stars, and galaxies. That classification is already one level, and then you can go deeper for what types of planets, stars, and galaxies there are. So stars were the first to be classified, especially after we developed the capability to conduct spectroscopy, which is essentially looking at what stars are made of in the 19th century. And then galaxies are then classified, which finally separates them from nebula since they look kind of similar. And it happened in the 1920s because that's when people realized that they're not in our galaxy, there are other galaxies. And then planets were then separated into different types of rocky planets. You have gas planets, icy planets, and stuff. And then now we have to do this for exoplanets as well. So, yeah. So to classify planets, so obviously we have to call Earth terrestrial. So Terra is Earth, so Terra is terrestrial. And that made Earth a planet, which means that planets are like this now. And then we have gas giants, or Jovian planets. So Jovian essentially just means it's Jupiter-based, since Jupiter was pretty much the first gas giant we discovered. So gas giants are just like this.
Jovian means
ice giants,
giant.
which are a gas giant is just a planet that's mostly made up of gas, like in the case of Jupiter, hydrogen, helium. And then ice giants are made up of ice, not just water ice, like methane ice and stuff, because they're located farther away from the sun. And then there's also pulsar planets, which orbit around pulsars, which is a very recent discovery. And then dwarf planets. And by IU definition, we have dwarf planets, which are essentially stuff like Pluto, unfortunately, which used to be a planet but is now not a planet, and stuff like Ceres. And then we have exoplanets. So I'll skip that. So here's how stars are classified. So who here can tell me every single star type, just the main star types, without looking it up on Google?
Like the color classes, like spectral types.
Yeah.
Also
George, you want to do
temperature,
that?
I think.
OBAFGKM.
Okay, that works. So do you guys want to know a really nice way to memorize it?
Is this the kissing one?
Yes.
Dang it.
Yeah. So does anyone know it?
I do.
Yep. Do you want to tell everyone?
No.
Okay. But this is a mnemonic that some people use to remember stuff just because it's kind of funny. So the star types is O, B, A, F, G, K, M, right? So what we do is we just say, "Oh, be a fine girl, kiss me." So that's all the letters of the star types in that, and that's how you easily remember them. So yeah, just don't tell anyone I told you that, right? So this is the main This is classified by spectral. So it's classified by temperature, so how hot the star are. So we have M class, which is the lowest temperature, O class, which is the highest temperature. And then there's also the MKK. Obviously, these fine people named it after themselves because that's how people are. This is based on the physical nature. So we have luminosity classes, which is just how bright the star is. And then you might have seen this before, right? The HR diagram. So this is absolute magnitude or luminosity over temperature. So the higher the temperature, usually the higher luminosity it is, obviously, because more energy is being poured out. So this is what we use mainly now, the HR diagram. So you guys have seen this several times. No, I'm not going to further explain it. And then we have the classification of galaxies. So before I scroll down, you might have already seen it. But who can tell me the 3 types of galaxies? Yes, George?
The 3 classifications are the elliptical, the spiral, and the unformed without a set form. Okay.
Yeah, they're irregulars. So we have those. So those are our galaxy types, and then inside those we have even more galaxy types. So for example, this is pretty much how it works. So the tuning for classification of ellipticals and spirals. So we have elliptical 0, which is a perfect circle or a sphere. Then we have E3, which is like an oval. Then we have E7, which starts looking like a spiral. And then we have spiral A types. So just regular spirals just look like that. The higher the second letter, the more spread out the spirals are. And then for SB, so spiral B, which is barred spirals, then you'd have a large bar in the center, along with more arms. And just the higher, same with normal spirals, the second letter, the third letter in this case, the ABC, will determine how spread out it is, kind of. And you see we have some beautiful sketches of galaxies. So this is most likely done on paper. So if you want to do astronomy sketching, there is an observing award for that by the Astronomical League. So if you want to do that, you can draw the stuff like this. Then there's also an award. So there's the award, and there's also a Sketchers Award for money. So maybe, you know what I'm saying? So then, just like we have the 3 domains in biology, we also have the 3 kingdoms of astronomy. So we have planets, stars, and galaxies. So this is pretty analogous to biology, and that's what we have here. So we've already gone over them pretty much. So just like we all have taxonomy in biology, so we have the levels. So each level being higher than the top. So we have Animalia, so let's say kingdom of animals. And then you can get more refined down to whatever that is. Then you can go down to the vertebrates. And then you can keep on going down to mammals, primates, hominids, and then us, so Homo sapiens. Yes, Arif?
What about nebulae?
Nebulas, they're not really, you can't really, since they're so, irregular, you can't really classify them. There are...
You can classify them.
But there are planetary nebulas. You can call them that kind of stuff.
You can classify them like... You can classify them like emission nebulae, dark nebulae, planetary nebulae.
I don't think I have it on this slide, but yeah, so those are some types, I guess. So, and then there's taxonomic levels in biology, we also have them in astronomy. So we have types of stars. For example, we have stellar kingdom, so stars here. And then we have just a regular star, because there's other stuff in there as well. Let's say we have post-main sequence, and we have a post-main sequence giant with luminosity class of 3, and it's either an FGKM spectral type, and its special type is an R Lyrae star, which is a cool type of star you should look at. So, yeah. And then going back to here, so this is just a summary of the 3 kingdoms of astronomy. So planets, we've known about them for a long time. So we just call them wanderers. So, and because Copernicus was smart and thought the sun was actually the center of our, oh my god, that hurt my ears, sorry. And just like Copernicus thought that found that the sun is the center of at least our solar system, and because he's so smart, like other planets were recognized that they could possibly be Earth-like or just like shaped like us. And then stars were, back then people thought they were fixed just in the sky. They're just moving along with the celestial spheres and just like placed there. And then Bruno in the 16th century recognized them, that they could be possible like other stars, just like our sun. And then in the 19th century, we fully understood them pretty much. And once we got to spectroscopy, because then we can look inside and see what they're pretty much made of. And then galaxies were known about since 16th century by Magellan. And in the 18th century, people started thinking that they could maybe be like other universes or stuff. And then in the 1920s, we realized they're not. Some of them we thought were nebulae, and then we realized they're not. They're actually galaxies. And then in the 1950s, these have been continually published in all astronomy textbooks. So yay. And then we have the 3K system. So this is just 3 kingdom system. So there's 3 kingdoms, 18 different families under the kingdoms. So we have stars. So in the kingdoms, we have stars, galaxies, and planets. 18 families under those. And then under those, we have 82 classes. And then a bunch of types and subtypes. So the 18 families are here. You have protoplanetary, you just have a planet, circumplanetary, subplanetary, interplanetary, medium, and planetary systems. And protostellar, star, just regular star, circumstellar, substellar, interstellar, medium, stellar systems. And then protogalactic, just regular galaxy, circumgalactic, subgalactic, intergalactic, medium, and galactic systems. And this is all based on the strength of gravity, and that's what makes up these little families here. And then we have these 82 classes. I'm not going to read out every single one of them. You're going to get the presentation later. Don't make me work extra to do this. So, yeah. And then there's more, by the way. There's 2 whole pages. So, but then there's, obviously, with any classification system, there is some issues. Just in general, the main question is, what is a class in astronomy? So, like, what are they? And, like, it's defined, but, like, how do we define them? And what if we discover something that's like new, and how do we recognize that it's a new class without just like shoving it in with the rest of the stuff? And this obviously shows that discovery is an extended process, which means we have to have our classification system. You have to keep on refining it, keep on making it better, and make it more expansive. And this obviously takes place both before and after what we're looking at. The nature of what we're looking at is known, so we can see if it doesn't even belong to any classes, and if it's a new one. Yeah, someone has a question? Question? William?
William on mute.
Can you read out all the classifications?
Could you say it louder?
Can you read out all the classifications?
No, I will not read out all of these classes. You can do that yourself. I am not going to take my time to do that, by the way. My bad. All right, and then we have...
Hudson, do you mind if you can slow down a little bit? Thank you.
I guess. Okay, and then we have this. So this talks about why we need a classification system. So this shows what level, like what we're looking at is in the hierarchy. So we can see like a little question here. So let's just say, like, is a hot Jupiter a new class of object, or is it just a special type of gas giant? And we have to see, like, we have to essentially just ask ourselves, like, is the actual nature of the object different enough from everything else to make it a new class? It's like that's what makes it really hard to do this kind of stuff. So, like, classification is such a confusing topic because there's no official like thing telling us like this, like whether something is a new class or not. So there's also some philosophical challenges to this. So like there's also like so obviously we made up the classifications of this stuff. It's like, does that mean that like so that means we have control over this, but then so we have like artificial criteria, but then what are the natural criteria of this stuff? So like which like natural characteristics that are not designed by us or not like set out by us describe objects? So that's like a really big question when we're working with this kind of stuff. So, and then this is just essentially a definition of class for biology. So membership in a class is just determined strictly on the basis of similarity. So just how, so if two things are similar to each other, they're probably going to be in the same class. So on the possession that certain characteristics are shared by all and only members of that class. So it's essentially just everything in the class shares certain characteristics. In order to be given a class, atoms must share certain features where it must share certain features with other things in that class, and if they're not in a class, then and it can be reclassified as well too sometimes. This is just from a random book in 1988. So yeah. Then for astronomy, this guy who made this class system rejected like the biological definition, but it still works for astronomy. So often in astronomy we don't actually know characteristics of objects because they're hard to see and stuff. So we have to do a lot of digging to be able to find the characteristics so we can actually classify them. So there are a lot of unclassified objects out there that we don't know whether like they're one thing or another. So yeah. And then this just shows like what discovery is. So since it's an extended process that takes a long time, since discovery started, like for astronomy specifically, started hundreds, maybe thousands of years ago, with like people just looking up into the sky. So it starts off with detection. So you have to know what stuff is there, and then there's interpretation. So you have to know what thing is there, and then understanding. So we have to find out what we're looking at is, and we have to find out what it does and how we know why it's like that. And then before discovery, and then for discovery, we can see that we can theorize about stuff before we actually see stuff. Like for example, I believe black holes might have been, like they were theorized before they're actually discovered in real life. And then after discovering something, there's credits and rewards and stuff that you have to do. And then you have to classify of the thing itself. So, yeah. So there's these two parts, pre-discovery and post-discovery, where you can classify some stuff. So you have to have some sort of quick understanding of it. So like, is it a planet? Is it a star? Is it a galaxy? You usually see and then tell what it is. And then you can classify the actual thing itself fully after like you fully understand what it is. And like exactly like for example, like if you look at a star, you might not know exactly the spectral class or anything, but you know it's a star. But then if you do more digging to get an understanding of that object, then you would be like, oh, this is just a G-class star. It's just like that. So, yeah, and also for nebulae, so I think we touched on this before, but this is Herschel, is a super nice guy. Essentially, we have all these nebulas, and there are 42 different morphologies or types of nebulas. So, good luck remembering all of these, but yeah. So Herschel's classes are divided into 8 different classes of nebula based on appearance. Then this shows how classification is an iterative process, as later we now have 12 classes and it's based on the actual physical nature of it. And then today we now have 6 just modern classes, which I think is better than 42, right? So here are the 6 types. So we have the reflection nebula, which is the Pleiades, for example, which is where there's interstellar gas and dust, which reflects light from nearby stars. Then there's globular clusters, which are just essentially big, giant balls of stars. And then we have planetary nebulas, which look like planets and this kind of stuff. And then we have specifically some like hydrogen alpha regions or H2 regions, like this, where there's a lot of star forming. And then we have spiral galaxies, which are class Gs, because this was, I believe, made before we knew when galaxies were actually separate from nebulas. So I think they used to accidentally include galaxies in nebulas, which is pretty funny. So Herschel essentially gave preliminary classifications to nebulous objects based on just what they look like, but then he didn't have the tools needed to determine the physical nature, so like spectral class and stuff. And then there's also more stuff that we found out, like we found pulsars, which are predicted, they're theorized literally as neutron stars, but then we realized that they are different because they're pointing at us pretty much based on their physical nature. And then there's quasars. And there's so many stuff similar to quasars, like radio galaxies, blazars, and it took them time to classify them as actual active galactic nuclei, and it's based on energy output, which is still related to its physical nature. And then black holes were predicted, and they're seen as like evolutionary endpoints of stars, so we've seen some of them. There's supermassive black holes. I think the first time we've observed them was in 2019. So that's the first time we've seen them, not like, and that was still indirectly because we're looking at the stuff around the black hole. So yeah. And then discovering new predicted classes. So for example, neutron stars and pulsars. So these two fine gentlemen here theorized that these could form from supernovae, specifically neutron stars. And then these other two guys, Hewish and Bell, discovered pulsars while looking for quasars. So they actually discovered that. And then people thought it was like aliens trying to communicate to us. But then they realized it was because of the Doppler shift from the Earth's orbit. So does everyone here know what the Doppler shift is? So the Doppler shift is essentially an effect where if you have a moving object, like waves emitted by it ahead of it are compressed, which means they're higher frequency, and waves behind it are stretched, meaning they're lower frequency. So that's why when like a plane is flying over you, it's first high pitched, and then it goes down to like a low pitched rumble. And the same with like an ambulance. You can hear the siren getting higher. So you have a high pitched siren as it approaches you. Then as it goes away, it starts getting more and more low pitched. So I hope that helps. So yeah, and then these two guys who discovered this pulsar then started speculating about like radial pulsations from they could maybe be from white dwarfs or neutron stars, and then they realized that these aren't pulsating; they're rotating neutron stars. So, and that's how you get that. And then this is another example of discovering a new class. So quasars, are class G8. So we have a bunch of like radio sources in the sky. So people think there may be like radio stars in our galaxy. And then this guy here found just looks at this object here and finds that there's very broad emission lines. And then he realizes that these are just hydrogen lines and they're super, super redshifted. And they are very far away, like billions of light years away. So he either like some super power source or like some like redshift of a star inside a galaxy. And then they realize that it's outside of the galaxy. And then they declare that quasars are a new class of radio source based on their immense energy. Very impressive, like objects. And then I've talked about this a few times, but then you have the black holes because these were predicted. So we didn't look. So we pretty much like guessed that they existed before we like actually observed them. So the idea of a black hole like this dates back to the 18th century. And then Schwarzschild, you might recognize the name since the Schwarzschild radius. So based on Einstein's theory of general relativity, gave them a mathematical description. And then Oppenheimer, the guy who made the big boom, the big bomb, gave them the first modern description of what a black hole is. And then they're also one explanation for why quasars and active galaxies emit so much energy. And then we realized that then we have this X-ray binary, Cygnus X1. It's expected to harbor a black hole because, just looking at it. And then Hawking concedes that it is actually a black hole. So, yeah. And then we have the very controversial ones. So everyone knows that Pluto used to be a planet and is classified as a dwarf planet, right?
Of course.
Yes. Yeah. So in 1930, they found Pluto, and then they didn't know how large it was. But it was designated a planet because it kind of orbits the sun, I guess. And then even until 1978, they still didn't find the mass. And until they discovered Charon. And once they discovered the moon Charon, then they could interpolate the mass. And then they realized that Pluto is actually 0.2 times the moon's mass. They thought it was the mass of Mars, but it actually is not. And then they realized that the asteroid 2003 Eris is possibly larger than Pluto. And then they realized that there's a bunch of other objects like this, the Kuiper Belt objects, KBOs. And then because of that, and also because of the IAU's definition that planets must clear their orbit of other objects, so since there's a lot of Kuiper Belt objects, they declare Pluto a dwarf planet. But it is actually not a planet, which is very unfortunate. So it looks like one, obviously. You can see Pluto's like a nice round sphere. And it's moon Charon, but it is not a planet, it is a dwarf planet, unfortunately. So here are the classifications of planets specifically. So Copernicus first made the terrestrial planet classification, so like Earth in 1543. And then gas giants were then not really accepted, and they were only accepted around 1940s, 1950s. And then we have ice giants, which were classified by Voyager 2 when they went to visit the ice giants So Uranus and Neptune. Then pulsar planets were theorized and looked at by these two guys in 1992. And then dwarf planets were you haven't cleared the orbit thing in 2006 because they didn't want like 100 planets or something. So, and then the amount of planets in our solar system, this is what I found very funny, but like the amount of planets in our solar system has changed a lot as a definition or classification of planets has changed. So in ancient Greece, we only knew about the wandering stars, so because these planets would move differently from stars. So we only knew about Mercury, Venus, Mars, Jupiter, and Saturn. So we only had 5 planets. Then Ptolemy, in around like 1500 or 1400 or something, found that there's he included the naked eye planets, which are regular ones: Mercury, Venus, Mars, Jupiter, Saturn, including the moon actually, and the sun. So now we have 7 planets. So apparently the sun and moon are planets. Then in 1610, Galileo did some things with a telescope and found out that there's actually 4 moons of Jupiter. So obviously that added up to 14 planets. And then Copernicus then finds out that this is a heliocentric system, so everything orbits around the sun. So Earth is then added as a planet, and the sun is demoted as a planet because the sun is a star, not a planet. And then by 1684, because of the advent of the telescope, Saturn is discovered to have 5 large moons. So that adds 5 to the count. And then in the 18th century, they realized that moons aren't actually planets. So then they just strike off the 10 moons that we've discovered. And then in 1781, Uranus is discovered, so that adds 1. And then between 1845 to around 1801 to around 1845, we discover Ceres, Paula, Vesta, and Juno, which are all asteroids and stuff, or dwarf planets nowadays, as we call them. So that adds to 11. And then Astra and Neptune are then discovered in 1846. So Astra is another asteroid, I believe, and then that adds to 13. And then in 1846, from then on, asteroids are now they're now distinguished from planets. And then so that's a 5 asteroids gone. And then 1930, they discover Pluto, so that's 9. And then 2003, stuff starts popping up like Sedna, and then 2005 Eris, which are all Kuiper Belt objects. And then there's obviously a lot more than that. And then in 2006, the IAU makes a controversial decision to demote Pluto and not to promote Eris, even though Eris is larger than Pluto and stuff, so everyone's angry about that. Now we have 8 planets in our solar system. And yeah, we only have 8 planets, although it could change as classifications are refined in the future. So this obviously teaches us a bunch of lessons on this, but to conclude pretty much class, so the class is determined within a classification system to determine the levels. So we have classes, the underclasses are type, and under that is subtype, and so on and so forth, as we get more and more precise. And then the criteria that's most used to determine the class status of astronomical objects. Oh, I forgot to turn off annotation. My bad. So the most used criteria for determining class status is the physical nature of it. And initial classifications are based on just what you look at, are useful in just detecting it. So like, is it a star, is it a planet, is it a galaxy? And then final classification awaits determination. So you can only determine that once you have full understanding of the thing itself. So the physical nature, like spectral type, where you actually just can't straight look at it. And then obviously reclassification at this stage is very common. So this is all part of like astronomy. So discovery, classification, and definition are part of philosophy and astronomy. And there's like a fusion of that, along with history, because you have to know how they classified it before, and just philosophy of science. So there's a lot of stuff going on that's not just looking at stars and stuff. And that's it. So if you want more information, you have these books that are definitely not sponsored from Cambridge, and by this guy. So I believe Tyler now has a booklet that we will play. So
real quick, for extra points, who made the announcement at the International Astronomical Union meeting when they demoted Pluto? Somebody, an astronomer that's been talked about this week, made that announcement. Anybody know who it was?
That's for gravity points.
Yep.
Can you
we
need our gravity points from those spin the wheel.
Yeah. It was Jocelyn Burnell Bell, you know, the person that discovered pulsars. He actually made the announcement at the International Astronomical Union demoting Pluto. Okay, on to Tyler.
Right. Tyler, you there?
Okay. So our next activity is
Can you
daily
look at
photo
again?
share, which is going to be led by Hanson. Hanson, actually, we could do a book in between.
Yeah, can you host it
Yeah.
since I'm so busy now?
And we're gonna do monsters, bro.
Then you make the closing slides then, Hanson.
No,
So
I'm still working on the video.
can you just host it in like a different screen? I need to work on these slides.
What?
I need to work on these slides.
No, I'm working on the video for tomorrow, because we're presenting it over for 300 people.
Fine.
So.
Hey guys, what game mode do you guys want?
Real quick.
Monster Brawl.
Hanson,
Monster. Not Monster Brawl.
Hey, guys, wait.
What were you
Kevin?
saying, Kevin?
Oh, Hanson,
Monster Brawl.
Tyler, are either of you guys going to be at the Star Party tomorrow?
I will be
don't-
late.
I don't know if I will be there tomorrow.
Okay.
Unfortunately, I'll try to come, I guess.
It's
I'll
9 to
be
10.
there tomorrow.
What do you have tomorrow, Hanson?
We're watching the
I'm
World
just
Cup.
thinking for kind of, when people come up and ask about it. So.
Okay.
I'm
Since we're watching
coming
the World Cup, if it
tomorrow.
ends, I
Why
could
is the
come late.
screen like halfway?
It's
Is
9
it
to
9
10.
to 10:30?
Can you do crypto
9 to
hack?
10. Okay.
I should be able to
Can
do
you
it
do
by
Gold
9.
Quest?
should be able to
Can
make
you
it.
do something
Gold
other than
Quest.
Gold Quest?
No,
I'll
Gold
be-
Quest.
I can do
we bring the
Monster
library
Brawl.
closest as well.
Monster Brawl.
Crypto hack.
I did
Please,
promise Monster
Monster
Brawl
Brawl.
after the Deceptive Dinos.
It's fine. Can we please do Monster Brawl?
Okay, we
I
will run this
hate
for
Monster
15
Brawl.
Let's do 10.
minutes.
Well, he promised it.
After this, we'll do the photo share thing so you guys can share your SLOOH photos. Hanson will be
Need
running.
links. Are we doing anything special today because it's the last day of camp?
What do you guys want to do? I set up another Jeopardy.
Oh, nice.
You guys want to do Jeopardy
We
after
can
this?
do a game kit.
Yeah, I can run a
Maybe
game kit
not.
too. The other thing is that we might keep doing meetings like this just for SLOOH stuff if you guys want. Do you guys want that?
Man.
We
Sure.
could do random talks like this.
Sure.
Set up times.
I'm good. Yeah. Yeah.
Okay.
Sure.
Either way, I'll have your emails, so yeah.
Sure.
Bert.
Wow, imagine not having any chromas.
Hey, I have 2.
What is a chroma?
And I bought one from the store.
I'm very new for this. What is a chroma?
Yeah.
It's a blanket.
Basically, it's a level higher than legendary.
Okay, is everybody in that wants to be in? I remember there were 13 people last time playing the
Maybe.
blanket. Okay, then we'll be starting in 5, 4, 3.
Can we not do the dramatic talk?
Okay, no. Mandy is not in. Okay, Mandy.
1, 2, 0. 0, 2, 1. Let's go.
Where occurrence of Mandy not having a seizure? Is Mandy's
Guys,
last
it's a
name
99 point.
Okay, there we can start.
It's a
Okay, there we can start now.
0.01% chance of happening. Mandy not happening.
You accidentally X'd out Mandy, I think.
I did not.
Okay.
Maybe you did.
Everyone's so locked in.
Why is it so quiet?
We're all
It's
locked
because
in.
everybody's locked in.
Bree, are you locked in?
Yep. Nope. Not really.
Then you have to lock in because if you don't, you will lose.
Come on.
Someone say something.
Hi.
Say again. I'm testing my speaker.
Hi.
That works.
Finally, dark energy. This late, bro. Okay, that's a bad situation. Might be little species. Who is winning?
In the Geo Party.
Oh. Low temperature and low luminosity. Oh,
When is it?
start? It just made me restart. It just made me restart.
Tyler, can we do Geopardy?
What does Geopardy mean?
Jeopardy.
Fair Jeopardy.
No, we're not playing
Unrigged Jeopardy.
We're not playing Jeopardy.
Jeopardy is
Why
boring.
not?
Jeopardy is boring.
Dang, crazy.
Yeah, we're not playing Jeopardy.
Oh, Jen. Alright, yeah.
I'm not playing Jeopardy.
Definitely have Jen.
I'm not playing Jeopardy either.
If you guys play Jeopardy, I'm just gonna sit here.
I want to do something.
What grade are you, Justin? What grade are you, Justin?
4th.
Okay, yeah, that was kind of obvious, but like.
I wanted to do something.
Will, want to do Jeopardy?
I want to do something with Tinkercad.
Oh, let me lock in.
Bro.
I want to do something with
Tyler, what's after this? Tyler, is it another presentation?
I feel like Tyler left the
Bro.
We have another presentation after this. It's a very short presentation. Just a
after that, what's that? After that short presentation, what's that?
Originally, it was planned for Jeopardy, but it seems like you guys don't want to do Jeopardy.
We don't want to do Jeopardy. No Jeopardy.
Why are all the 4th graders hating on Jeopardy? I need to grow up.
Hurrah. Hurrah.
He's dead.
Where's Hurrah?
He went to go take a swig. Actually, he's too young to do that.
Yo, I think Hurrah is still here.
You want me to give another long lecture presentation? I can do that.
Wait. We should do spin the wheel so I can get more gravity points.
Hurrah.
Yeah, you.
Bro, he's not here, Justin.
I went to the bathroom.
You went to that. What grade are you?
I'm in 4th grade.
Yeah.
See, I told you, all the 4th graders are hating on Jeopardy.
All these youngins.
Well, yeah. We're not playing Jeopardy, not at all.
Yeah, see.
We're not playing Jeopardy.
Jeopardy is the baddest game ever.
We played Jeopardy once.
Baddest.
Wait, see, they say baddest. This is why 4th graders are like
baddest.
So
Baddest
like
is not
so
a word,
terrible.
actually.
Baddest
Baddest
is
is not.
Yes,
it was one of
not a
your
word.
kind that said the word.
What?
It was one of his kind that said the word.
Well, what do you mean by that?
Said that baddest is not a word.
Shri, which grade are you in? Shri.
Going to
Shri,
sixth
Probably
grade.
like six, yeah. See, at least he still has more brain cells to lose than y'all.
What do you guys want me to run? I can do.
Okay, then fine. Game kit. Game kit. At least do game
No.
Okay, not game kit. Then what are you gonna do?
Something that isn't anything you want to do.
Well, all the 6th graders just can't choose. Like all the middle school.
We're not all 6th graders.
I mean, all the
Room
middle
temperature.
schoolers just can't choose.
Ask Hanson what you guys should do next. He has a lot of stuff. Unless, what do you guys want to do?
And also, baddest is not
I
a
was
word.
being
It's a slang
horrified
version of
by
bad.
like every single thing.
6.
4th place, mainly because I was spamming until I nearly ran out of health.
There was
this giants.
There were giant
zombies
chasing.
Bro, I got
Even
to like level
birds.
32 and then nearly died.
I even saw a giant bird.
Nice.
There's a giant bird. I got like giant crabs, giant like steampunk duck things.
Do you want me to show you random websites that you guys can use?
The useless web.
Nah, that's boring.
Ooh, this one would be fun. Gravity simulator.
Gravity what?
And I didn't see any like
Tyler, give me some gravity
blue
points.
zombies in the
You're
end.
gonna have to ask Anna about that. She said that she was gonna get gravity points.
Tyler, you give me gravity.
I need GP. Let's do spin the
You see,
wheel.
if
Let's do
Rob,
spin
how
the
much
wheel.
GP you got?
Oh wait, let me check.
He probably has like
I'm
2,000.
gonna check it. I'm gonna check it.
I
before
don't
you
have
can check
2,000 actually. I have
Actually,
1,914.
we can do this
I have
after.
1,914 actually.
Oh, I'm about to get higher than you.
Okay, after this presentation, we're doing a quick space activity. Actually, daily photo share time. Hanson.
can I share?
Yeah, we're gonna get Hanson over
Can I
here.
share? I haven't ever shared
I don't
before
have
for
access
reasons.
to SLOOH on this computer, by the way.
You have, yeah, just log into your SLOOH.
I want to share.
Bro is asking me to do all the work. You lazy. Your video should not take this long. You've been working on it for 4 hours or been playing video game noises.
I'm also working on that presentation as well, which is 20 slides.
Okay.
Can you give me gravity points?
I can't
Guys,
directly
let's
give you
just
gravity
do
points. You
spin
have
the
to ask
wheel.
Anna to give
I
you
already
the
got
gravity points.
I already got 2 questions correct. Let's just do spin the wheel.
I'll summon you guys some gravity points. I'll ask Anna to give you guys some.
Give
Yay.
me one. Give me 1,000 gravity points.
Give me 1,000,000.
You can't get 1,000,000.
You see, if only if you were the son of
It would-
Neptune, aka the CEO.
Well, actually, 10,000.
Only if you were the son of
It's only
Neptune.
for like 89,000.
Actually, I'm gonna change my name right now. I'm gonna change my name.
Yeah, that's not you guys. That's
Too
definitely
wild
not you guys.
Rob.
But the
Alright,
CEO
I
is
thought
only
you were
like
son
level
of
5.
Neptune.
And then apparently there's a few people who are level
Son of
9.
Neptune.
She wants to start Stargazer with an outrageous amount of gravity points. Share your photo.
That's a tried and test. That's a tested way of getting gravity points. If you take good pictures.
Here.
That one.
What is this line at the end? Does
I
anybody
have
know?
no idea.
Hanson,
Wait,
tell
I think
them.
I think bro tried to like put together the red filter and the blue filter to make like a color image. And
I
then,
didn't do anything to
And
this.
then bro, so I think like they tried to like superimpose the red filter and blue filter, but then they kind of failed and diagonal shifted the red filter.
I know there was one photo in the community which was like this, except there was no photo at all. It just was blank and it had a bunch of lines on it, and it looked like artwork. So he posted it.
So you've been copying other people's work. How disappointing. Disappointment.
Bro, where are your copyright firms?
I can never be like that. Anyways, the main problem with this photo is chromatic aberration, hence the blue lines. And okay, Bode's Galaxy, present this.
I took this like 3 months ago. The reason this image exists is because I scheduled an advanced mission, but then I forgot about it, so it just gave me this one image in return for it, I guess.
Oh. Okay, why are there so many trees? Okay, Andrew. Okay, actually. Show us your very cool photo. Actually, of the Eagle Nebula, actually. Why did these all look the same? Okay, Andrew, show us your photo of the Lunar Nebula. Are you here, Andrew? Okay, does anybody have a photo they want to share in the chat? Okay, so is there anybody? So there's no photos anymore, I guess. Okay, I guess I can like all your photos for gravity points.
Yay, he's actually giving us gravity points.
check mine. 이거 내 늘어.
My sister's being super brave.
What? 7.
I said you're really brave and I'm really scared.
Wow, you're such a really good
Man,
person.
these people need to man up.
Mine is Unicorn Hero. That's my name.
So I guess there's no more people that want to share. Liking does give a lot of gravity points. That is true, but that's because I'm a teacher. So yeah.
Did you like mine? Did you like mine? Please like mine, bro.
Can you like one of mine?
Maybe I can share mine.
Scroll to the first quarterman or something. I need a.
Actually, yeah. For your awards, whenever you like do this, I'll give you gravity points. Like
Did you
whenever I
find
give gravity
mine?
points, it's like 35 each.
Can you
Can you like my replies?
Like
Can you like mine?
Like my replies. Like my replies. Like every
I give a lot of gravity points as a teacher.
Like every day. Like every day.
Actually, we'll do this. Whoever wins the bucket, I'll like their post.
I won the last bucket.
I can't do it.
Post your
Whoever
post.
wins the whatever we do.
Does anybody else?
No, too bad I can't see mine because mine is like in the bottom, I think. Somehow.
Okay. Here, go ahead and like all of them then. What you can like your
But my moon. What about my moon? Right under test. Right under test. My moon. Yay.
Eddie, I like your.
How my Mars?
I give you a lot of gravity points. I give you 100.
Thank you.
Can you do the upper one like my Mars?
Where?
Up.
Up.
Go up.
Okay.
Tyler, give me gravity point.
You see, I would, but you're like old.
Oh, so you just don't like it.
Where is
We'll
yours?
see.
Oh, I'm not
We'll
in.
see how it is.
I'm
We'll
in
see.
your.
Mine is at the bottom, like
Windows pane.
my Ego Nebula. And my Mars is up there.
So yeah, I give a lot of gravity points. So
Yeah, Tyler, I'm in your final thing.
I'll go ahead and like yours too, William. You did win a bunch of buckets. You were a good child. Actually, you're literally my age. Oh, this.
Wait a minute, does everyone else's SLOOH accounts like expire in a year?
Yeah, everybody's expires in a year.
Yay.
Yeah, but like Brett said, they're free accounts, so.
Mine
Unless if you're a
doesn't.
task member, I have, because SLOOH has a deal with my school, I have like infinite, as long as my school keeps paying for the contract.
I paid like $30 at the start, like a few months ago.
Enjoy your gravity points.
Do everyone's.
Oh, looks like I have no one.
These are some random people I don't know.
I think people need to give to the random people.
Yeah. Okay, so that's our photo share button. That's a good photo, George.
Can you click do can we see never mind.
We have a leaderboard. William, wow, you're doing so good. 2023.
Guys, we know exactly why it's 2023. He's doing it right now.
Eddie, 1997. Oh, I didn't know that you were
Wait,
born.
wait, wait, watch this.
Wow, Eddie, you're so good.
But I don't know, my photo deleted, so I'm posting in the chat.
Oh, you're such a good child.
My
What?
photo.
I'm
wild,
kid.
One of my.
Okay, yeah.
I had first color, now I have grayscale, and it deleted my observation.
Yeah, it does that sometimes. It's a bit buggy. But anyways, William has quite a few gravity points. You guys need to catch up. It's a SLOOH song.
No,
You guys
it's
need to be like
because
him.
he's using the strat that I taught.
What are you?
He's
Tyler,
using the
what are
strat.
you? You're not a SLOOH song. What are you?
Me,
William,
I
stop
don't
using
care
this.
to dwell among you poor people. Like, I only have 383, but I'm a teacher, so I can kick you out at any time, so you get zero
Yeah, so
gravity.
William, bro.
I can archive
How
your
does
account
William have
and
2023 gravity points?
But you see,
I don't
Hanson,
know.
Hanson?
Yeah, Hanson.
I've actually done
Hanson.
stuff with the platform. Hanson is something else.
Yeah, Hanson locked in.
Yeah, Hanson.
Worse than everybody.
I haven't really used because I have my own
that's-
telescope. But yeah, I guess yeah. Also, I'm leaving more slots for you guys to do missions. So
That makes no sense. They all have their own set of missions.
I'm leaving slots open.
No, they have as many as they need. You can only have all limited. You can't like steal their mission stats.
Oh wait, Eddie, your gravity points went up.
Yeah, I wonder why. Maybe because Tyler blocked my image.
Tyler probably just gave you too much.
Yeah, Tyler gave me too much. I wonder why it's.
Yeah, Tyler might have given so much.
You want me to assign you quests?
No.
No.
It's
but
schoolwork.
Can you ban Eddie and William from using the chat?
Why?
What did you
for-
do? I mean,
for
the
this
strat, because like that's not fair. William already got like 2023 points. This is not fair.
Why
at all.
are you like discussing
Rob,
the
it's the
thing?
same thing as spamming quests.
Oh, should I give more gravity points to William?
No.
Yes.
I want gravity points. No, I get
No,
gravity
no,
I
no,
points.
want gravity points. I want
Don't
gravity
give them to
points.
me. Give them to
I-
William. Don't give them to me.
I
Give
have
them
the
to
least
Will-
gravity
to
points.
Give them to Eddie.
Well, except
No,
7.
give them to William. William, you deserve
Eddie
the
needs to
gravity
make more
points.
points.
William does
Can I
not
have-
deserve any gravity points.
I need more
Rob,
profit.
you don't.
William needs more profit. William needs more profit.
Tyler, can you comment?
How does
can
William
you,
need more
Tyler, can you
profit when
type
I?
something? Can you Tyler, can you comment on one of my things and see what it does?
It doesn't. It just
You
gives
see, I would, but that's a lot of work for me.
Yeah, exactly.
You press a button and type cool. That's it.
I'm not. My name's not Arnold. So who do you want me to comment on?
Wait, I have
2,132. Me.
Okay, I'll comment on one of yours. Sure.
Yeah.
But you have to promise to win John Wagner next year.
Oh.
And Horkheimer. If you guys all join, you guys can also win. I haven't talked about the benefits that you get. So it's just like $500 equipment just right there for submitting a form.
No, he's doing an ad. No.
Rob, what's not fair?
William, you should apply for Horkheimer, and you can still apply for John Wagner. You actually have a good chance of winning.
What's John Wagner?
Okay, there, oh, you got Zorak of England. Welcome to SLOOH, Stargazer. Okay, so that's our daily photo share.
Oh wait, I remember what John Wagner is now.
I'll give the boring end of camp presentation I have to give.
Make an award ceremony.
Actually, Hanson, you're presenting it. You're presenting
I'm
your
so busy.
presentation.
Bro, I'm so busy.
Didn't you say you made a presentation? Mine, I just AI generated mine and
No, I did make a presentation. The presentation I'm making is for the thing I have to present tomorrow.
see, guys, whenever you find teammates, find a reliable one.
Come on, I have research to do.
That's crazy.
I believe you have research, but there's no way that it takes. I've been working on it since at 4:21. Since like 1 o'clock when this meeting has started. I mean, you've been at UTD since 8 o'clock, right?
What?
It's been 12 hours. No, it's not been 12 hours. It's been
Since what, guys? It's been
10
12
hours since 8.
So,
Can you not finish a presentation in 10 hours?
My
oh,
friend once
we're not
completed a
working on the presentation.
500 slide presentation in like 2 days.
Okay, I'll go ahead and present the summer camp. Okay, so the SLOOH and TAS summer camp. This is the closing ceremony. Enjoy. So this week we have some incredible numbers. We had 62 registered students. We had 20 hours of YAP, and we had 30 highly engaged students throughout the days, and 7 SLOOH executives.
Wait. Can you name who was highly engaged?
Eddie was one, Shri was one, Arav was super engaged. McDonald's person was engaged. William was engaged. Wesley was
Why do all of these
chasing.
presentations
George was
look
super
AI generated?
engaged. This one is AI generated. I didn't have time to make one.
Wait, so
So
are those numbers real?
our key partner spotlight is SLOOH. The global robotic
Nice.
has a global robotic telescope network.
Yeah, this is definitely AI generated.
So
Yeah, I don't know what you
That
think.
guy's chin. It's.
so our main organizers, mainly I organize everything over here. In fact, I was the one that organized the entire summer camp in general with the schedule and the forms. So hope you enjoyed everything that we did this week. Hanson presented a bunch of presentations. Also thank him for that. His space propulsion was really cool. I have no idea about any of that. So here's like what we did throughout the week. And a slow scavenger hunt. I made a presentation, and then Hanson did space propulsion. This is a formula. Can anybody tell me what this formula is?
Delta V. I think it's like it's a rocket equation of some sort. The it's a rocket equation. I'm pretty sure.
George?
I think it's part of the law of ideal gases.
That is correct. No. Good job, George.
I know that thing is delta V.
Also good. So for Tuesday, we had SLOOH talk about women in astronomy, which wasn't really women in astronomy, it's just random historical figures. I talked about the Harvard telescope and gave stuff on the Tinkercad. And did you guys all enjoy the presentation that you guys had to make for that activity? That's more of a hands-on
Not
one.
really. Not really.
I
Not
could
enough time.
kind of could tell because like a lot of people dropped off. There's only like 20 people left at the end of that. So that's that. So Wednesday, Milton and Keith gave a presentation. They were cool. They went for 2 hours about instead of the 1 hour. Then there's a astrophotography camp. AI typed this wrong, not me. So this was basically a daily photo share, and then astronomy research, basically astrophysics, no, astrophotography and stuff. If you guys have any questions, you can ask us. We're always available for any questions about astrophotography. In fact, we could probably host seminars for that if you guys wanted to. So on Thursday, SLOOH talked about stellar nucleosynthesis and sun's ultimate death. And then Kevin, thank you for him. He gave a fun presentation about telescopes. I hope you guys all learned whenever you're buying telescopes later. I know George has one. I know Shri has one that Kevin gave him. And then I talked about white dwarfs and neutron stars. And then Friday, which was today, we had our keynote speaker, the CEO. Remember to make your avatars, guys. Don't forget. And email them to Anna. I'll put out Anna's thing later. And then remember also to join IAY and TAS. If you're if in the Texas area, join TAS. If you're international, join this. That way we still have a way of communication for any events that we're hosting. And then I yapped about solar system formation, and Hanson yapped about classification. So this was the daily photo share yap. This is our student engagement analysis. So this is our star party information if you want. I'll send out more information later. But that's basically it.
Wait, let me take a screenshot of this.
Okay. Okay, clear skies ahead.
Okay.
So yeah, that's the camp. Hope to see you next year. Okay. So our next activity that I totally didn't just plan is we're gonna watch this. It's kind of like the one if the moon was 1 pixel thing.
Oh.
I wonder if we're doing a game kit.
I'll run a game kit after this. Can you guys all see this?
Oh.
Yes. Wow. I've been to this place before.
Oh, it's gonna be the thing where it like zooms out and then.
You know this website?
Yes, I know this website.
It's gonna zoom out and then give you a seizure. Whoa, that's cool. Oh, it said light.
Why is this Chrome experiments?
I just have these random resources and stuff, which is
Where's
fine.
the asteroid belt? Oh, asteroid belt disappeared. Oh, it's called Alpha Centauri.
There's more than just these stars. There's actually a lot more.
Oh no, is this a star cluster? Yeah. Local cluster. Ah! Black hole? No.
Forgive the glitching. It's kind of hard to simulate all of this.
Milky Way.
Oh, now we're zooming in? What is this? It's gonna be a black hole, watch.
Okay, so that's that. So if you guys ever want a cinematic view of the Milky Way and stuff, or a cinematic video, you guys can use this. So that was the short little fun thing of a day. So do you guys want to do a GIMP kit now, or do you guys want to do the Jeopardy?
Game kit.
I hear a lot of asks for Jeopardy. I didn't know that Jeopardy was so popular among you guys.
It's popular a lot. It's popular with everyone except the fourth graders.
Mm.
I'm a third grader.
So what do you guys want besides GIMP kit?
Jeopardy.
I just want game kit.
Okay, we can run GIMP kit then if everyone wants to.
Are we doing Jeopardy or not?
I can run Jeopardy if you guys want. Jeopardy or GIMP kit.
Game kit.
No Jeopardy. No Jeopardy.
No
Okay.
Jeopardy.
I
No
hear a lot of
Jeopardy.
voices approving of Jeopardy, so we're gonna do Jeopardy.
No
No
Jeopardy.
Jeopardy.
No
No.
Jeopardy.
No
No
Jeopardy.
Jeopardy. No
No
Jeopardy.
Jeopardy.
No
No
Jeopardy.
Jeopardy.
No
No
Jeopardy.
Literally,
Jeopardy.
all the third graders.
No
it's literally
way.
just 4 people. It's literally just 4 people disliking Jeopardy.
No
Because they're
Jeopardy.
graders and the 4th graders.
I
Okay,
guess.
finish the presentation. Finally.
Okay, how will you present it?
It's not related to astronomy though.
It's fine. We did one about classification of biology and stuff.
No, but that like relates directly to astronomy though. This one's about heat exchangers.
Yeah.
And I'm not
Gas
even
exchange.
speak heat. I'm not even gonna speak the entire
We
part.
have a presentation
It's fine. Just skim through it.
You guys actually want to see it then?
Yes.
We have to get a popular vote.
Sure.
Raise your hand if you want to see the
guys,
presentation.
raise your hand if you want to see Hanson's presentation.
Maybe.
Two hands. We need a majority. We need
3
11.
hands. 3 hands. Let's go. There's.
Come on.
We need.
Hanson,
We,
raise your hand.
we need.
Wait,
we need
where's the
7
raise hands
We need
for?
7 more hands. Let's.
How
we
many
need
people?
7.
Who wants to see me? Who wants to see our presentation?
Some people here are inactive, so.
6 more
I
hands.
guess 5.
6
5,
more
5.
hands.
No. 5 hands is good. 5 hands is good.
What
6
does
hands is good.
what does the raise hands mean?
If anybody objects, talk right now. If there's no objections, then we'll go.
What does the raise hand mean?
I object.
Oh, so
I
Sibin
object.
objects.
I'm gonna host the
Sibin
game
objects.
kit.
There's one objection out of 5.
Okay, fine.
Objection. I'm an objection.
So there's 2 objections.
Out of 7 raised hands. I think we all know.
We know who won.
Okay. I see the majority. So.
Yeah.
I'm doing I'm hosting
Here we
a
go.
game kit.
You guys hear it?
We
You
already
guys see it?
know.
I'm hosting a game kit.
We know that you're induced.
You guys hear it?
Interesting.
You guys see it?
Yeah.
Yes. Hopefully.
Okay.
Are you actually hosting a game kit?
First this.
I might.
Do you guys see my screen?
Maybe, maybe not.
Yeah.
Okay, so today, as a surprise, I'll be talking about the optimization of TPMS, triply periodic minimal surface structure based heat exchangers. So here's what we've been doing over the last 6 weeks. So to start off, first week we learned about physics, fluid mechanics, heat transfer, and CFD software through lectures. And then in the second week we did some more learning about MATLAB, and then we learned about ANSYS software, which is a super powerful industry grade software. And then week 3 to 5, we performed a bunch of numerical simulations where we ran CFD simulations in ANSYS Fluent to sort of like understand how fluid would flow through our structures. And then the last week, which is this week, we've done data analysis visualization using the CFD Post app and MATLAB, and then prepared our final poster and this presentation. So our problem statement. So to start off, a heat exchanger is a device used to transfer heat between 2 fluids without the fluids themselves mixing. And the problem we want to solve is that increasing energy use requires more efficient heat exchange and cooling in power systems. So an example of this would be thermal management for EV batteries and data center cooling. So the question we want to ask is there a way to improve heat exchanger performance? Well, there actually is. So the solution that we've derived are TPMS structures, triply periodic minimal surface structures. These are mathematically continuous geometries, which are just generated using these math equations up here, that display zero mean curvature, which means that they have the most amount of surface area per volume. And as you see, high surface area to volume ratio, which makes them excellent heat exchangers. So here's the methodology that we use to create this. So to start off, we drew a little picture on paper of what our structures would look like and how we were going to set our boundary conditions, which is essentially just how hot the fluid is, how fast it's moving. So we have a hot fluid inlet and outlet and a cold fluid inlet and outlet, with the hot fluid set at 450 Kelvin moving at 0.1 meters per second, and cold fluid moving at 0.1 meters per second, but it's only 300 Kelvin. So no, you will not get this presentation, by the way. So here are the meshes that we created. So we prioritize the actual TPMS structure to make sure that we use the most amount of computational resources on that. So here are the meshes for all of this. So the inlets are a lot shorter than the outlets because we did not want any backflow, which would be problematic and poison our thing. So here is a first simulation. So this is the primitive structure. This is the one I'm working on. So this is called a velocity streamline. So each one of these arrows represents one particle moving through the structure, and as the lines get redder, that means the velocity is faster. And I also do want to point out this also shows Bernoulli's principle, as in a system like this where the volume gets compressed like this, where there's less volume as it goes through these little tiny channels, the velocity will increase, although the pressure will drop. So, and then as you see the next one, next we have the diamond structure. This is a slightly different structure, and as you see, this one has a lot more drag, so same as the last one. This is a velocity streamline. And then we have the gyroid structure. This one has the least amount of resistance, so fluid flows through more freely, and mixing is heavily encouraged. So here are some of the result graphs that we have created. So to start off, we have the heat transfer rate. So this is just how good the heat is transferred through the TPMS structure, and how many watts each side has lost. So for example, see here for gyroid, the hot fluid has lost about 10,000 watts, but for the gyroid, gyroid's cold fluid, it's only lost about 9,500 watts. Then we have the LMTD, so the low mean temperature difference, which is the difference in temperature between the hot and cold fluid. As you can see, the diamond and gyroid are higher than the primitive. And then we use these metrics to sort of get our heat exchanger performance. So we have this thing called delta P, which is the pressure drop. And as you see, because the diamond and gyroid are similar structures, they have a pretty comparable pressure drop and have a high heat transfer coefficient. But then we see that the primitive has a abysmally low heat transfer coefficient, and it has a very high pressure drop and a low at the same time. So this is interesting because, as you see here, on one side, on one of the inlets for the primitive, there's a very small pressure difference, but on the other side, there's a very large pressure difference and a lot of pressure drops. These are all contours that we've made using ANSYS Fluent. And this shows that a very interesting and unique property of the primitive TPMS structure. As for the hot fluid, it will flow straight through the center without much mixing or impinging, which means that there's a lot of surface area that is wasted, and that is no bueno. So a solution that we are thinking on is adding more inlets and outlets, which will then cause an impinging flow, and that impingement will allow it to fill the space more efficiently and to come in contact with the walls and fix the heat transfer coefficient, because the heat transfer coefficient is very low for a shape with such a high surface area to volume ratio. So in conclusion, over this project we performed numerical simulations to study heat exchange using these TPMS structures, and we found that the diamond structure has the highest HTC coefficient and the heat transfer rate with a comparable pressure drop to the gyroid. And due to a very asymmetrical structure, the primitive TPMS structure showed a significantly larger pressure drop, but still had a large heat transfer rate. And a potential thing is that we could use AI to run additional sets of cases, so different boundary conditions, maybe even changing the actual parameters of the geometry themselves and the formulas, so that we can potentially try to narrow down the most optimal TPMS structure of each type. So that is it then. Something didn't load, my bad. Yeah, that's it.
Okay, any questions for Hansen? And it's very.
Yeah, any questions, guys? Because I'm presenting this tomorrow, and I do need to answer questions.
You guys all understood that? 90%. Impossible.
If you guys actually understood this, you guys got to join mechanical engineering. You guys have to. If you just straight up understood that, you guys go to go learn mechanical engineering. Like you found your calling.
You guys lying to me. I don't like liars.
There's no way you guys understood this, right?
Okay, so that was a very, very inspiring presentation by Hansen.
That was just a random.
Arav is asking questions about what the what. If you could respond to that.
What the what? Yes.
Oh, will we get his presentation? Can you post your presentation, Hansen?
No, I'm not allowed to post this.
Yeah. Okay, so we won't be able to get his presentation, George.
Tyler, I was saying what the what to all these aerial tramways.
Okay, then next activity will be a game kit or Jeopardy. Uh,
I'm hosting the game kit. I already started it.
I believe so because actually
What?
Can I post the link in the chat?
No.
no, if we're gonna host a game kit, I'm gonna have to host it.
Okay, because I already started it.
No, either that or you do Jeopardy.
Geo party. Geo. Guys, show of hands. Show of hands. Who
I
wants
do not
Jeopardy?
see any link.
Raise
Show
your
of
hand if you want
hands.
Jeopardy, and like lower your hand if you actually raise your
Raise your
hand
hand
for
for
Jeopardy and raise your hand for citizen card. Yeah, raise your hand for Jeopardy.
Guys, raise your hands.
No, actually,
Raise-
lower your hand for Jeopardy.
William, lower your hand. Yeah, let's go. Let's go.
Then raise your hand for Gimkit or something.
Yeah, raise your hand for Gimkit.
1, 2, 3, 4.
Wrong. Sorry, not.
4. 3, 3, 3. Only 3. 2, 2. Only 2. Only 1. 2.
I guess
One.
that's 0 people that wanted to look at it.
Who are the lane? Who are like
4 people.
But in-
4 people want Gimkit. Everyone else wants.
leading?
I guess nobody wants Gimkit then.
No, there's the lady in our hand raised. Yeah.
I guess nobody wants Gimkit. I guess
No, because there's the lady now raise hands.
Wait, that's actually kind of funny. Are you actually doing that?
No,
We're trying to, but we can't.
Hey, yo, this is so good. Bro, I could just hear Tyler's spam clicking.
And guys, stop. Like,
Okay. I'll get it. We'll do Jeopardy.
Yeah.
no, it's because they delay. Someone must delay our raise hands.
Okay, I'll go ahead and do Gimkit. I get it. You guys really want to do Gimkit. There's like 6 people asking for it.
There's only 4. There's only 4.
I can host it. I can post it. I can post
There's only 4
You're
people.
not
There's
hosting
only
it, Arav, because we don't have share
Fine.
permissions. Nobody can see your screen too. And you'll probably cheat by searching up the
How will I cheat?
Because you get to see the answers.
I'm gonna use the impossible kit.
Okay, impossible kit. Astrophysics. Okay, yeah. You guys actually might know some of this. Anyways, what game mode do you guys want?
The monster's wrong. Monster wrong.
It's Blick. It's Gimkit.
It's Gimkit. Oh, Gimkit. My bad.
You
Gimkit.
guys don't even know what you guys asked for. What is this?
It's Gimkit. Can we just
Jeopardy,
who
Jeopardy.
catch? Wait, actually, never mind.
Jeopardy.
Okay, Jeopardy?
No, Gimkit.
Jeopardy.
No,
Gimkit.
Gimkit.
Okay.
Gimkit.
What game mode do you guys want?
Yes.
Don't look down.
Don't look down.
Don't look down.
No. Don't look down.
Don't look down.
Don't do that. Look down.
the flag.
Absolutely
Don't look down.
Never do. Don't look down.
Never do it.
Trust no one?
No.
Dystopia.
Can you capture the flag? Capture the flag. Capture the flag.
Wait,
go down.
Capture the flag.
Go down. Snowy survival. Snowy survival.
Yeah.
Super rich mode?
Snowy
Easy cycle.
survival.
Hidden mode? Drain mode? Boss battle?
Snowy survival.
Snowy survival.
Knockback?
No, snowy survival.
Snowy survival.
Do snowy survival.
Snowy
Snowy brawl. Snowy survival.
Snowy survival.
Can we just do snowy survival?
Just do snowy survival.
Why are you so slow?
So what do you guys want to do?
Snowy survival.
Raise
Snowy
your hand
survival.
Be quiet, Arab. Raise your hand for snowy survival.
Rob, are you serious?
Okay,
You're not gonna raise your hand? Okay, good.
okay, so only two people.
3.
Okay, so two people.
3 people. Oh wait, my hand is getting deleted. My hand's getting deleted.
Okay, so only one person for survival. Raise your hand for
Our hands are getting
knockback.
deleted.
There's 4 people. Oh my
Raise your
god.
hand for knockback. Okay, two people. Got it.
No, no, but wait, let me take off my
What
hand.
is
I'm not.
this?
I'm no, nope, not me. I'm not doing knockback.
Okay, so raise
Just do
your hand for
snowy
capture the
survival.
flag.
My god.
Just choose it.
Oh my god, do snowy survival.
Tag domination. What is that? Can you try that?
No. I played that one. Do not play it.
Also,
Why
I
don't
can't
capture
even
the
do this
flag?
mode. I have to do the feature
Capture
ones.
the flag.
If I do the 2D one,
Snowy
you have to pay.
survival. Snowy survival.
He said
Flag
he
of the
said
Okay, now that everybody's
we
quiet.
snowy
survival.
survival.
Okay, now that everyone's quiet, I can finally say this. I can't do the modes over here. I can only do the feature ones and welcome to Game Kit ones because those are free. The other ones are all paid. So it's between capture the flag and knock back. Which one do you guys want? Why is it so quiet now? Can you guys not speak? Uh, you should now try.
Yeah,
Okay.
now you can speak. Can you capture the flag?
Okay,
Can
let's
you
do
knock
capture
back?
the flag. Capture the flag.
Don't look
Allow me to
down.
speak.
Don't
Knock
look down.
Knock back.
Capture the
Knock
flag.
Guys,
back.
we've
Don't
done
look down.
knockback the past maybe 2,
Capture
3
the
times. We have to do
flag.
capture the flag
Dude,
now.
don't look down. It's
Capture
obstacle
the
course.
flag.
Dude, don't
Don't
look
look
down. Don't look
down.
down. Don't look
Don't
down.
look down. Don't look down. Don't
Raise
look
your
down.
hand for
Don't
don't
look
look
down.
down.
Don't look
I
down.
raise my hand. I raise
I
my
raise my
hand.
hand. Don't look
I
down.
raise my hand.
I raise
3
my
people.
hand.
3 people.
4 people.
Okay, raise your hand for capture the flag.
Oh, delete your hands, guys.
Delete.
1.
One person,
2.
2 people.
Yep. Don't look down wins.
Raise your
Don't
hand for
look-
knockback.
Eddie wants you to do something
3
in the chat, I
people.
guess.
There's
3
4 people who
people.
wanted don't look down, so don't look down wins.
Don't look down
Oh,
wins.
wait a minute. Oh, wait a second. Oh, what if I just like raise my hand? Oh, I guess it's a
No.
tie.
I think
Flag
Eddie
is
wants
almost
something.
over. Can you just do
Tyler,
don't look down?
I think Eddie
Wasting
wants
time.
something. I think Eddie wants
We'll
something.
go ahead and just do don't look down. It'll be
Yeah.
20 minutes.
I
Thank
think
you.
Eddie wants something.
What do you want, Eddie?
Perma mute everyone. My headphones already turned off 3 times because they're yelling so loud.
Okay. You've been perma-muted. You're no longer perma-muted. Okay, here's the code. Everyone can see my screen, right?
Yes, sir.
Okay. Go ahead and play. Have fun. Enjoy the last day of camp.
Okay. Thanks.
Hey, wait. I'm about to join.
Wait a minute.
Don't get drunk. It's not good.
Hi, Seven. You're pink.
Hi.
Okay, I guess we'll start now.
Wait. I'm not in. I literally clicked join. I'm not in. Oh, I'm in.
Okay, now we're starting. Okay, enjoy the last day of camp. Do you guys have any questions?
Let me make sure.
Hey, 还没有上完课。OK。
Hello.
We're doing a kimchi. It's like Kahoot. Red sign is classified. I think it's a main there. Hmm? Main seed is concentration.